research scholar from the ISTAR field, immense pleasure to welcome you all on the second day of the 2 days National Conference on Emerging Trends in Biological, Chemical, Computer and Interdisciplinary Sciences, sponsored by GSPTM and Kuchkos, whose continued support strengthens the research, innovation and scientific excellences across the state and the nation. As we begin the second day of our national conference, we are delighted to start the first technical session with an insightful lecture by Dr. Sanket Joshi, Professor and the Deputy Director at the MIT Institute of Microbial Technology from MIT University, Rajasthan. To felicitate our esteemed guest with a bouquet as a token of our respect and gratitude, I would like to invite Dr. Nisha Dakshini ma'am to felicitate Dr. Sanket Joshi sir with a bouquet. Thank you sir and ma'am. Now I would like to invite Dr. Shilpa Gupta ma'am to give a brief introduction of our esteemed guest.
Very good morning to one and all, my dear colleagues and all dear participants and students of UG and PG program of Biological Science. And as we are starting today the technical session, our first speaker is Dr. Sanket Joshi, as it is mentioned by the anchoring person. So I am very much pleased to give a brief introduction of him, as he is my very old colleague of NVPAS, and I am really very happy to give an introduction of him. So currently Dr. Sanket Joshi is Professor and Deputy Director at the MIT Institute of Microbial Technology, MIT University, Rajasthan. He holds BSc and MSc degree from Sardar Patel University and PhD from MS University, Baroda. With over 21 years of experience and additional industrial R&D expertise, his research area include microbial enhanced oil recovery, biofuels, biopolymers, and environmental bioremediations. He previously served as Deputy Director of Oil and Gas Research Center and as an application specialist at Sultan Obaz University, Oman. He has overall 160 scientific publications, national and international, include 107 international papers and 32 book chapters, 20 international books and 1 Australian innovation patent, and 70 conference abstract is also on his credit. He has guided 41 undergraduate and graduate postgraduate students, and 3 PhD students have taken guidance in India as well as in Oman. He was awarded as NRI Senior Scientist Award from Microbiology Society India during academic year 2019 and 2020, and also the Fellow of Society for Plant Research in 2025 by Society for Plant Research. With this brief introduction, I would like to invite him for his talk on microbial technology in action from old field to ecosystems. So I request all the participants to listen his talk carefully, as it may be a part of your curriculum, as well as definitely I am very much sure you will enjoy his session and be interactive at the end of the session also. So thank you very much, and once again I welcome him.
morning, everybody.
Good morning, sir.
चाय पी के आए हो ना? तो थोड़ी नींद कम आएगी. So thank you, Shilpa ma'am, for the introduction and the organizers for giving me this opportunity. So Vidyanagar is my hometown. I don't belong to Vidyanagar. Vidyanagar belongs to me. So it's always good to come here and talk about it. So थोड़ा सा मेरा जो introduction दिया वो देख के पता चला होगा that I am I don't know master of anything or not, but jack of many things. So I'm fortunate enough during my tenure of past 25 years or something to work in more than 20-30 countries and to have a piece of everything. बाहुबली थाली की तरह मैंने हर जगह पे जाके research किया है. I got opportunity to learn from best of the best in the world and contribute. So I'm a microbiologist by background. Uh, Chemical engineering, petroleum engineering, nanoscience, health science, industrial scale-ups and everything. उन सब में थोड़ा सा यहाँ वहाँ सीखा and contribute किया. So I'll be sharing a little bit of what I did over the past 22 years or something in India and abroad. So I'll be speaking mainly about microbial technology because I'm a microbiologist and applications all the way from oil field to ecosystem restoration and everything. Okay, technology. So this is how technology is about. So basically what will we learn during these coming 60 minutes or 70 minutes or something. So we'll see because my main research was funded by petroleum industries and I was working in a Middle Eastern country and some parts where oil was available, not in India. So we will learn about current state of affairs of petroleum industry and what next for the industry as such. And why I'm doing research in petroleum or why one should be worried about it. So पैसा है नहीं तो क्यों research करना है? We learn about it. So money making, it's an era of Atmanirbhar Bharat and all. Our Prime Minister is pushing for it. So it has to have some money making thing. But we just don't want to make some money. We want to save the environment. पैसा कमा लोगे लेकिन अगर environment खराब है तो कहाँ जाके रहोगे? So we need to take care of environment also. सिर्फ पैसा नहीं बनाना है. So where microbes are helping it, that also we will see. And I'll speak a little bit about biosurfactants and renewable energy because we don't have a lot of oil in India. We'll speak about gas hydrates and everything. So what are the opportunities, challenges and everything? We'll speak about it also. So this slide I am trying to summarize here. It's fine. सब कुछ आसानी से होगा तो याद नहीं रहता, थोड़ी दिक्कत होनी चाहिए. So ये फिर भी ठीक है, स्लाइड से नहीं चल रहा होता तो बड़ी दिक्कत हो जाती है. फिर 1 घंटा वर्बल स्पीच देना पड़ता. As a professor, I can do it, but it won't be fun for you. So in this slide, what I'm trying to cover here is what is going on in this petroleum industry, as we know, or something. So you can see there is something which is going down and a word OPEC. So it's basically a mafia, it's a cartel which decides आज सुबह उठने के बाद या कल रात को सोने से पहले कितने डॉलर्स पर बैरल में ऑयल प्राइसेस होने चाहिए. If they feel मार्केट ओवर फ्लड कर देते हैं, so they will open the tap. बहुत ज्यादा ऑयल मार्केट में फ्लड कर देंगे. If they feel चलो थोड़ा और पैसा बनाते हैं, they will stop selling it and everything. So it's a cartel. OPEC is a group of petroleum producing countries and some non-member countries are also there. So this is what is going on. Prices will go up and down. And then there were some, not rumors, some scientific papers कि there is no more oil, peak oil. Oil is, जितना oil था वो सब publishing, sorry, produce कर चुके हैं. So there was a theory about peak oil, कि अब oil बचा ही नहीं है. Then there was a toxicity, of course, as a fossil fuel. So we know more population, more industrial outputs and everything, we need more oil, we will use more fossil fuel. So toxicity is one of the issues. Something amazing happened during COVID time. When we were in Middle Eastern countries and we were working with some oil companies and oil producing nations. So oil prices were in minus $30. What is it? It's so when you are into oil production, ऐसा नहीं है कि आपने एक बार oil production start किया और नहीं चाहिए तो नल बंद कर दो. मतलब ऐसा होता है ना कि when you want to stop the water flow, you can just close the tap. It doesn't work like this. Once the oil is produced, it keeps on flowing, whether you want it or not. So market was overflooded with oil, and they were paying you $32 per barrel. Please आओ और लेके जाओ. I'll give you the money. So this is what happened. So all those things makes us wonder कि करना है क्या? What is going on? Is there any future? So दो चीजें चलती हैं. ऐसा लगता है कि it's only doom and gloom for petroleum industry. End is near. Not really. इसके लिए थोड़ा और पीछे जाना पड़ेगा. We need to go back to civilization जब इंसान ने आग जलाना सीखना स्टार्ट किया. So I normally correlate it with it all started with fire. When did all these things started? So discovery of controlled use of fire and everything, it gave us an edge as a human species. हमारे forefathers or whatever in the beginning of, so उन्होंने आग जलाना सीख लिया. So they found out it's quite good. खाना भी पका सकते हैं. Different kinds of animals and all, you can ward them off and everything. So fire was a very good discovery. So initially we started with plant-based wood or coal जलाते थे, animal dung and everything. And slowly हमने sea voyages and all we started doing. So we started exploring the sea. समुद्र को भी खराब कर दिया. In the picture, if you are into reading, you can see the picture is from the Moby Dick. It's a novel if you are into fictional books and everything. So they started hunting whales and everything. So whale produces something fatty molecule. It's a kind of oil. So we started hunting whales just for the liquid gold, which was the oil. And then we discovered crude oil and everything on the land. And since then, around 150 years or 200 years or something, we are exploring oil and all the fossil fuels everywhere. So this is what is the beginning of the story about petroleum industry and everything. So even though renewables will be the future, we have to rely on it. But still, there is a very high possibility that we will be still using crude oil-based things and everything. Why so? This is what the slide summarizes it. That life without oil is not as simple as we think or as we want to go for it. Why? Because we correlate oil or crude oil with transportation fuel. कि हमने गाड़ी में पेट्रोल डालते हैं, केरोसिन डालते हैं एरोप्लेन में, and maybe diesel and everything. But that's just a fraction of crude oil or fossil fuel industry. That's just a small fraction. बाकी की सारी चीजें हम यहाँ पे use कर रहे हैं. If you can see in this picture. So there are plenty of things. In the morning when you wake up and you snooze your alarm, maybe on a mobile phone or something, it's not about plastic. Components, circuit board, this, that, you clean your teeth. It's surfactant. It's a chemical product. You wash your head, you take shower, khana khate ho, you cook your food in a Teflon coating thing, you go in a car, so everything, so anything and everything, till you go to the bed in the night, almost everything is made up of fossil fuel based derivatives. So it's a huge market. So this is not possible that we will entirely leave it. So oil and oil derivatives will play a bigger role. Then you also what about transportation? So these are some of the data which were published by different agencies are there. OPEC is there, BP is there. So they say they forecast scenarios and everything. The future में क्या होगा? 5 years down the line, 10 years down the line. They collect all the data, statistics and everything. So what they are saying is like renewables will play a bigger role. Fossil fuels, hydrogen, biofuel, bioethanol. We are blending 20% ethanol in our gasoline and everything. They say gasoline in abroad, we say petrol. Diesel also, we blend it with 20% biodiesel abroad. So B20, B50, all those things you normally blend it with your biodiesel and everything. And hydrogen, it's a gamble which we are trying to sort it out. It's nothing new. Hydrogen was the first. Hydrogen aeroplanes were the first in the beginning and everything, but because of challenges, all we stopped using it. Now we are again going back to it, like the trains running on it or on a hydrogen cell. We are working on it, so you can have it in your car and all. But when you look at all the scenarios, what you are seeing here on the middle graph is the bottom green, fluorescent green kind of thing is how much oil will be still used. So it's almost the same up to 2050 or something. So still you will be using petrol for transportation part also because it's not possible in a growing country like India or in China where suddenly कल सुबह government ने बोल दिया कि no petrol vehicles. It doesn't work like this. You say no diesel vehicles. Not possible. फिर dark age में चले जाएंगे. So we will be using it even for transportation. So whether we like it or not, this dark material is going to stay with us for at least in my generation with all the advances. तो बायोलॉजी वाले पूछ रहे हैं सर ये सब ज्ञान बराबर है, वेयर इज माइक्रोबायोलॉजी, बायोटेक कहाँ है? So biotech microbiology is a main theme of your petroleum research or fossil fuel. First figure what you are seeing is school में सिखाया गया था. How crude oil is formed, how coal is formed and everything. It's because of pure chemistry and little bit of microbiology and other things here and there. Principles of thermodynamics and everything. So it took millions of years because of pressure, because of enzymes, because of gradients and everything. Everything got subsided. You should be thankful to dinosaurs and all. They are contributing to our fossil fuel and everything. So सब कुछ degrade होके we ended up having huge resources of fossil fuels and everything, which we are using it now. So microbes कहाँ पे काम में आएंगे? First of all, crude oil formation. So do we know how to do it? We don't know how to do it now. हमें पता होता तो मैं यहाँ पे खड़ा होकर इस बारे में ना ही रिसर्च कर रहा होता ना ही बात कर रहा होता. We don't know how to make crude oil because Mother Nature took millions of years and we are finishing it in past 200 years or something. We are exploiting. We are the worst viruses on the earth, humans. Viruses are not a problem. We are the problem. हमने उनको villain बना दिया. Actually, we are the villain. So अगर humans को gap कर दो तो earth will flourish like anything. I am a human, can't help it. So crude oil formation तो हमको अभी आता नहीं है, ऐसा कोई magic lab बना नहीं. You can use plastic and plastic pyrolysis again gives back you crude oil and everything. So we can do not formation of crude oil, but other than this we can work on all those things. Like we can use microbiology for upstream. So in any industry, there are two parts: are there upstream processes and downstream processes. Upstream is something in what you are bringing crude oil to the surface. In chemistry or in microbiology or in pharmacy, we use microbes and we produce products in our fermenter. And so after it is produced, we go for downstream processing. So microbes are playing very big role in upstream, which is improving the oil recovery. It can play a very big thing. So we'll see some of these things. In downstream also, like in oil field produce water treatment, I will share some of the slides. In accidental release, bioremediation, oil spill, polymers, acarbos, and everything. So we work on it. So these are the places where a lot of things are to be done by microbes. So I think most of us who are sitting here, they are not engineers, right? None of us are petroleum engineers. Gujarati Hindi. આપણામાંથી ને કોઈ petroleum engineers છે અહીંયા? Nothing. I don't think so. We all are mainly either chemistry or industry or something. So we need a crash course on oil recovery. How things works in oil industry. So this was published some years ago when X was still Twitter. So John Nash, okay, Mark Perry. So Mark Perry ने बताया था how oil recovery works for non-petroleum engineers. So काफी अच्छी analogy थी. So there are two nice sweet deserts are there. One is a donut. It's a jelly donut. So most of the oil wells are like jelly donuts. अगर आपको बीच में से jelly चाहिए, just put a straw and you suck it out. So it's very easy, simple process. It's the simplest oil recovery. You drill the well, and it's like a fluoropounder, it will come out from the well. So ऐसे ज़्यादातर oil wells है नहीं अभी, like except few jelly donuts in Saudi Arabia or Kuwait and some places here and there. What we have in most of the part of the world is the tiramisu. It's a nice dessert. I don't know French or Italian, but it's like a multi-layered cake. So अगर आपको बीच में से chocolate चाहिए तो आपको हर एक जगह पे. So you need to do horizontal drilling and then you need to do vertical drilling. So we are not talking about a cake or a dessert. We are talking about a huge oil reservoir which spans around 50 square kilometer or more than that. So it becomes very challenging when you want to recover the oil. So this is the new generation of oil recovery. It's very nice, but please don't get distracted by this film. It's a very challenging thing. Dessert lunch के बाद खा लेना. अभी oil recovery और microbes के बारे में पढ़ते हैं. So how the process works? तो इस slide में summarize किया कैसे oil recovery काम करता है. Everything starts with the discovery. जियोलॉजिस्ट बोलते हैं सेटलमेंट से आप कनेक्ट करते हो. ऐसा तो नहीं होता ना कि मेरे घर के पीछे मन हुआ तो मैंने गड्ढा खोदना स्टार्ट कर दिया और चलो ऑयल निकालता है. डजंट वर्क लाइक दिस. देयर आर प्लेसेस गोल्ड कहीं पे भी मिलता है. सॉरी कहीं पे ही मिलता है, कहीं पे भी नहीं मिलता है, दुकान में मिलता है. बट इफ यू वांट ऑयल यू कांट जस्ट स्टार्ट ड्रिलिंग ऑयल वेल समवेयर. इट्स वेरी एक्सपेंसिव प्रोसेस. सो आप ऐसे ही रैंडमली 100 करोड़ डाल नहीं दोगे. So if there is a surety, you find out, you start drilling. So when you drill the well, this is what happens in the first phase. It's a primary recovery phase. When you drill, this oil, natural gas, all the resources are with a very high pressure. For millions of years, they are compressed. So when you just drill the well, it comes out. So it comes out like a fountain. So it's like this. This is what we used to do when we never had mobile phones with us. हम लोग वो thumbs up को shake करके दोस्त को दे देते हैं. वो खुश हो जाएगा, thumbs up दे दिया. तो जैसे वो खोलेगा ना लेगा thumbs up में, because it's under pressure. That's what happens in oil recovery because the reservoir is under pressure. So when you drill it, the oil comes out like this guy. इसमें Mentos डाला हुआ है, but it's almost similar way. कब तक निकलेगा अंदर से thumbs up? जब तक pressure है, जब तक CO2 है. The moment CO2 subsides, there is no recovery. So same thing happens in oil recovery. Once you drill it in a primary recovery phase, no oil comes out because there is no pressure. So अभी क्या करना पड़ेगा? I need to increase the pressure. So how you can do it? You go for the secondary phase. बाजू में 2-4 oil wells drill करोगे and you start injecting water. Water is easy. Water is available. If it is onshore or offshore, समुद्र में drill कर रहे हो तो lot of water is there. If it's in desert or something, you need to procure the water. You increase the pressure and then you recover it from the producer well. But oil and water are not miscible. पानी और oil का जमता नहीं है. So what you need to do? You need to add something. थोड़ा सा salt डालना है, थोड़ा सा कुछ और डालना है ताकि उन दोनों में bonding अच्छी हो. That is tertiary oil recovery. By primary and secondary, roughly 20% oil you recover. Tertiary recovery, you use different chemicals. This is the part where microbes come into picture. You use surfactants, you use chemicals, you use polymers, you inject the steam, you do fire in your reservoir, it's called as a fire flooding. You do many things and then the oil recovers. So all those things will still let you get access to around 50 to 60% oil. Still 100% efficiency is not possible. But this is how microbes are also used. So you may say, okay, everything is fine. बहुत pollution होता है, sir. Why you are keeping on talking about oil? So this is what I discussed in the beginning also. People want to recover more oil, whether we like it or not. Why? इंडस्ट्रियलाइजेशन, हमको इंडस्ट्रियल नेशन बनना है तो हमको फ्यूल से एक्सेस चाहिए. कल अमेरिका बोल देगा कि रशिया से नहीं खरीदना है, कल नहीं, वो तो रोज बोल रहा है. वी कांट लिसन टू डोनाल्ड ट्रम्प, उसका सब सुन नहीं सकते हैं. अब मुझे वो यूएस में वीजा नहीं देंगे, बोले डोनाल्ड टच बोल दिया, तो मत करना. सो दिस वन ऑफ द रीजन इंक्रीज पॉपुलेशन. इसके बारे में बोलने की जरूरत नहीं है. श्रिया वर्ल्ड नंबर 1, हमने चाइना को पीछे छोड़ दिया है. गर्व से नहीं कह सकते, बहुत मेहनत की है इसलिए. नहीं की है. नहीं करना. सो कांट हेल्प इट, नंबर 1 समथिंग. दिस द रीजन. सो आपको चाहिए होगा, सबको एरोप्लेन में जाने की इच्छा होती है, और वी आर गोइंग बाय फ्लाइट. वी नीड टू बाय आवर कार्स एंड एवरीथिंग, सो वी नीड मोर एंड मोर एक्सेस टू फ्यूल्स. एंड वहां पे कोने में जो दिखा हुआ है, इट्स लाइक एज आई सेड, ऑयल सिर्फ फॉसिल फ्यूल में यूज नहीं होता है. देयर आर प्रोजेक्शन बाय ईयर 2050 और समथिंग, मोर देन 7 मिलियन बैरल्स पर डे विल बी नीडेड फॉर एंसिलरी पार्ट, फॉर एक्सेसरीज. आपको सब कुछ जो अपने घर में यूज करना है, बाथरूम में यूज करना है, किचन में यूज करना है, वहां हर जगह पे इन सब पॉलीमर्स की आपको जरूरत पड़ेगी. व्हाट अबाउट कंट्रीज वेयर वी आर प्रोड्यूसिंग ऑयल विच इज इन द सेंटर? ज्यादा ऑयल मतलब ज्यादा पैसा. वो सब शेख है, वो सब घूमेंगे अपने टॉयलेट्स और सब जो सोने के बनाते हैं, उनको पता नहीं पैसा डालना कहाँ है. So they need more oil. So more oil means more revenue. So of course, so these are all those things. So all those things are making us produce it more. Jada. We need to keep on producing it. So लेकिन जैसे वो tiramisu देखा, what is next for oil industry? आसान oil अभी है नहीं. It is more challenging. They have to give money back to the society because they are polluting the earth. तो उनको क्या करना पड़ेगा? अपना जो प्रॉफिट है उसमें से चंक शेयर करना पड़ेगा. They have to share the profit. ऐसा दिखाना पड़ेगा कि मैं सोसाइटी के लिए और सबके लिए कुछ कर रहा हूँ. I'm trying to do something good for environment. So कुछ challenges है apart from money. Upstream processes is very difficult because oil to be recovered are from really extreme environments. You must have heard about oil shale, which is a boom in US. Oil sands, which is in Canada and everything, they have a lot of oil sand. मतलब अगर oil किसी sand पे गिर गया हो, तो it's like oil sand. You go to the place, it's acres and acres of oil sand. So you need to collect a lot of sand, and उसमें से आपको fraction of oil मिलेगा, unlike oil reservoir. So it's a very challenge. Bitumen is there. Bitumen is a strike like coal tar, and then there is a heavy oil spill, produce water, and so on. So solutions क्या है? It's an industry where a lot of money is there. So industry is always R&D. They also do R&D like biology or chemistry or something. कुछ उन्होंने processes use किए to make efficiency better as well as integration of innovative technologies or renewables also into fossil fuel industry. कुछ methods हैं जो हम लोगों ने भी use किए and people are using worldwide. We are using surfactant polymer, alkaline surfactant polymer. We use microbial products like biosurfactants, biopolymer. Thermal, we inject steam. Steam will make it liquid and then oil comes out. And then we use deep eutectic solvents, ionic liquids, and so on. Many different things are there. It's a bed of research. A lot of research is going on. So we'll talk about microbial products for the session, not about other chemical processes or something. So what you can use if you are into microbiology, almost anything and everything. So you are aware of it, कहीं तो पढ़ा होगा, लेकिन पता नहीं होगा कि fossil industry में use होता है. So microbes are producing biogas, which is methane, hydrogen. So when you want to increase the pressure, you can increase the pressure of your reservoir by injecting the miscible gas. It's known as a miscible gas injection. So you can inject CO2. So CO2 is an acidic gas. So when you inject CO2 into your oil reservoir, it will be CO2 sequestration. आप CO2 को storage कर दोगे, and the oil recovery will also happen because it's an acidic gas. You can use methane, you can use carbon dioxide, and many other things. It's produced by microbes. Microbes produces acid. Acids are generally used for oil drilling, oil recovery, everything. Microbes are producing it. You can use different kinds of solvents, ethanol, acetone, butanol, and so on. We will talk about biosurfactants and biopolymer. And also microbes can be used. Microbes can be used in thieves zone detection or something. It's also possible that you inject microbes or grow microbes which are already there in the oil reservoir. So we'll see about some of these processes here and there. So focus is mainly on biopolymer and biosurfactants. So what is surfactant? Nice pictures in the center. We call it a detergent. Surfactants are a smaller molecule. They are a wonderful molecule because it has both hydrophilic and hydrophobic moiety. It's an amphoteric substance. Kal sunflower sir ne bola tha in a different context, but it's an amphoteric substance. So they like both. They like oil also. They like water also. So because of it, what it does, it reduces the tension at the interface of oil and water boundary. मैकडोनल्ड्स में पता नहीं आजकल लोग क्या खाते रहते हैं यहाँ पे, बाहर खाने जाते हैं। आई लव टू शेयर माई फूड विथ माई क्लॉथ्स। मैं जब भी खाता हूँ कपड़ों को गिराता हूँ, कभी जेब में से कुछ निकल आता है, व्हाइट शर्ट नॉट गुड फॉर अ पर्सन लाइक मी, बट मैं खाना गिराता हूँ। अगर व्हाइट शर्ट खराब हो गया तो पानी से साफ नहीं कर सकते हो, के ऊपर ऑयल चिपका हुआ है, फैट लगा हुआ है, क्या करते हैं हम लोग, जो बीच में रंगीन फोटो दिए उनसे साफ करते हैं, डिटर्जेंट्स, बिकॉज डिटर्जेंट्स विल डू, इट विल रिड्यूस द टेंशन, सो इट्स नोन एज इंटरफेशियल टेंशन। जैसे वो अलग अलग कंट्रीज के बीच में टेंशन होता है ना बॉर्डर पे, सो बीएसएफ जाके टेंशन को रिड्यूस करता है वहां के कुछ लोगों को हटा के। सो ऐसा नहीं, ऐसे एग्रेसिव बातें नहीं करनी हमको यहाँ पे। सो ये थोड़ा नाइसली काम करता है बायोसर्फेक्टेंट आपका सर्फेक्टेंट। So if it is produced by chemical industry, it is called as a surfactant. But as a biologist, when surfactants are produced by biological means, उसको biosurfactant बोल देते हैं. It is produced by plants, microbes and animals. Humans भी produce करते हैं. We produce lung surfactant in our lung. It protects us against the infection. जो भी infection होता है उसमें lung surfactant produce करके microbes को neutralize करता है. Can we use lung surfactant for oil recovery? Yeah, we can. But try नहीं करें. किसी ने try नहीं करने दिया. किसी ने हाँ बोला, मेरे लैब में आ जाना, तुम्हारे लंग्स को स्क्वीज करके थोड़ा सर्फेक्टेंट निकाल दूंगा, तो वो भी मना कर देगा। सो इट्स नॉट अलाउड सो फार। ह्यूमन सेक्रीफाइस ऐसे बुक्स में और उसमें या कहीं कहीं पे होता है, इट्स नॉट अलाउड। सो वी कांट गो टू एनिमल्स। एनिमल्स रेज करने में टाइम लगता है। यू कैन यूज एनिमल्स, आपको एनिमल मना नहीं करेगा, या मना करेगा तो आपको समझ में नहीं आएगा क्योंकि हम समझना नहीं चाहते। सो व्हाट वी डू, वी गो टू प्लांट्स। Plants takes a lot of years to grow. एक सीड में से एक प्लांट ग्रो होगा, एंड देन इफ यू एक्सट्रैक्ट saponins and everything, उसके बहुत सारे एप्लीकेशंस हैं। इट्स वेरी एक्सपेंसिव। वी आर इन अ हरी। इट्स अ टाइम एंड एरा वेयर वी वांट फास्ट फूड। हमको फटाफट चाहिए, क्लिक होगा बटन, थिंग शुड कम आउट। सो व्हाट वी कैन डू, वी गो टू माइक्रोब्स। E. coli divides at every 20 minutes. बाकी का microbes will fungi takes some time, 5-6 days or something, but the batch can be done much quicker. So we go to mighty microbes, we manipulate them, we optimize the process and everything, and we mainly work on biosurfactants from microbial sources. Same is polymers and biopolymers. Polymers, they are bigger molecule, unlike surfactants. It's not a small molecule. It is made up of monomers, dimers, and everything. Different kinds of polymers are available. Currently 80% plus, give or take 5% here and there. Most of the polymers, they are produced from polymer industry. कहाँ पे यूज होता है? तो सारे पिक्चर्स देखा है, आपका क्रेडिट कार्ड, आपका मोबाइल फोन, आपका syringe, you give it a name. These petroleum products are everywhere, and it is almost so cheap to produce. The purpose ये था कि ऐसा कोई स्टडी चीज बनाओ। When I was a kid, I used to go with my mother to buy things from there. वो कपड़े का थैली होता था या थैला होता था। अभी वो स्टाइल हो गया है। अभी गुची का थैली मिलता है जो वहां पे हमारे घर पे फ्री में मिलता था, पब्लिक उसको लेके जाती है, उसके ऊपर डीएलसी और ऐसा लिखा होता है। तो वो स्टडी था, लेकिन गीला हो जाता था। सो लोगों ने बोला कि ऐसा कुछ निकालना है जो थोड़ा ज्यादा स्टडी हो और गीला नहीं हो। सो प्लास्टिक केम इनटू द पिक्चर। नाउ उसकी जो स्ट्रेंथ थी वही अभी प्रॉब्लम हो गया। इट टेक्स 500 प्लस इयर्स टू डिग्रेड इट, और वो जैसे जैसे डिग्रेड होता है, माइक्रो प्लास्टिक्स, नैनो प्लास्टिक्स, पता नहीं क्या क्या बनता है। सो वी आर यूजिंग इट एवरीवेयर। Same thing, if you produce it by biological means, it's known as a biopolymer. Microbes are producing it as well as plants are also producing it. So, जब 2001, 2004, पता नहीं 2001 में तो ओलंपिक में था। So when I shifted to petroleum research or something, research करके we went to oil industry. We have a solution for you. You are doing pollution and everything, और आप चीजें यूज करें, chemicals are not good, तो उनको बुरा लग गया। तो मैं उनको समझाना पड़ता था उस टाइम पे कि why one should go for biological products when plenty of chemical products are already there in the market at a cheaper rate and it's working like magic. क्यों मुझे change करना है? I'm used to it. नया नया पॉलीमर हर साल निकाल के आ रहा है। So we used to explain it to them, which is much easier for them to understand now. There are several advantages when you go for biological products. They are non-toxic. Biodegradability के बारे में सोचने की जरूरत नहीं है. If it's a biopolymer, it will be degraded. If it's a biosurfactant, it will be degraded. So the first advantage we used to tell them is it's not toxic or less toxic than biological chemical products. Can be synthesized from renewable products. Waste product को लेके आप treatment भी करोगे और अपना product भी बनाओगे. It's almost equal or better than most of the chemical compounds in terms of oil applications. Surface activity बेहतर है, wettability alteration काफी अच्छे से करता है. It is useful in enhancing oil recovery, viscosity reduction, drag reduction, and many things. So we used to explain to them, and then ONGC gave us a project here back in 2004, हाँ 2004, 2005 में ONGC का प्रोजेक्ट मिला था पहले। महसाणा एसेट, महसाणा इज अ प्लेस इन गुजरात जहाँ पे हेवी क्रूड ऑयल प्रोड्यूस होता है। इट्स वन ऑफ द लार्जेस्ट ऑयल फील्ड। सो ओएनजीसी के आईआरएस चंदखेड़ा इंस्टीट्यूट ऑफ रिजर्व स्टडीज इन अहमदाबाद, उनके साथ में कोलेटिव प्रोजेक्ट किया था व्हेन आई वाज इन एमएस यूनिवर्सिटी बड़ौदा। सो ये सब एक्सप्लेन किया था। नाउ दे आर अवेयर ऑफ इट। बायोलॉजी काफी अच्छे से काम करता है, बट कुछ भी रिसर्च करने के लिए आपको पैसा चाहिए। So why I should give money to you? Or why you should work on something like this? I'm not saying कल सुबह अपना सारा research बंद करके you come with me and work in biopolymer biosurfactant, नहीं वो नहीं दिखाना चाहता हूँ, but दिखाना चाहता हूँ कि इस फील्ड में क्यों रिसर्च कर सकते हो. So we always want to materialize your research not just into paper or a thesis. It should be something good कि आपको end of the day 100-200 करोड़ बना लो और थोड़ा शांति भी मिले कि मैंने लोगों के लिए कुछ किया. So why what you can do if you are working in surfactants or chemical polymers. So if you look at the market, global surfactant market, biopolymers का डेटा नहीं देखा, it's much bigger. तो इसलिए मैंने उसको छुपा दिया. Biosurfactant को आगे लेके आ रहा हूँ. उसका market is more than $100 billion. So global surfactant market back in 22 or something was around $58.5 billion. Lots of zeros. मुझे पता नहीं बिलियन में कितने जीरो आते हैं, अभी याद नहीं है. 8-9 या उससे भी ज्यादा, and it's a US dollar. So multiplied by 19. It was around 58 to $59 billion, and they are saying it will reach around $100 billion by 2031 with a very healthy annual growth rate of around 5.7%. So when you look at biosurfactant market, it was around 6 billion or something back in 22, and they are saying it will reach around $8 billion by 2031. So it's still 8% plus growth rate. कहाँ पे applications होगी? हर जगह पे. जहाँ पे आप chemical surfactant use कर रहे हो, उन जगह पे आप biological surfactants use कर सकते हो. So ये slide पिछले 20 साल का काम है. 60 minutes या 80 minutes मिले तो 800 minutes तक बात नहीं कर सकता. So this is what our research group did in past 20 years or something. We have established a state of art research centers in Oman. वहाँ पे यूनिवर्सिटी के अंदर एक बड़ा सा रिसर्च सेंटर बनाया. Application was all in oil research क्योंकि funder was interested in oil. Biosurfactants can play a very big role in antiviral therapy, antimicrobial agents, and so many things. बहुत सारी जगह पे applications है. But funder wanted to see something to be materialized in oil. 5 different types of biosurfactants we found out, different kinds of biopolymers and everything we developed it for them. Some of the examples are shown here, and it is working like wonder, either alone or sometimes in combination. If you want to ask your oil company to stop using chemical surfactant, we can't do it in one night or something. So what you need to do, you say replace it with 10% of bio-based product, replace it with 50% or something. It may work better than both individually. So it is working well in a collaboration also. So this is what was our plan. Like chemical products, you produce your bioproduct, take it to the oil field, you inject it into oil well, it will go to the reservoir. This black material is the oil which will come out from the producer well. So you inject it from injector well, you collect it all with the produced water. It comes out with the water because it's a water-based system. And then you collect it from the producer well. So this is what was our plan. अभी तुम्हारे जैसे कुछ कुछ स्मार्ट लोग ऑफिस में यहाँ पे बैठ के पूछ रहे हैं कि इतना आसान था जितना आसान दिख रहा है. एनिमेशन इज मच इजी राइट. एनिमेशन में सब कुछ आसान दिखता है और टॉम एंड जेरी मारते हैं कूद देते हैं टॉम बन जाता है और फिर से टॉम बन जाता है जेरी बन जाता है. सो इट्स ओनली पॉसिबल इन कार्टून लाइक इन एनिमेशन. रियल लाइफ में ऐसा नहीं होता है. व्हाई? ऐसा नहीं है कि ऑयल का स्विमिंग पूल पड़ा हुआ है, आपने ड्रिल किया और नीचे से 1 लाख लीटर ऑयल निकाल दिया. नहीं, ऑयल इज इन बिटवीन क्रिवाइसेस. इट्स लाइक एंड द surface जहां पे मैं खड़ा हूँ. oil reservoirs, rocks are like this. It's very challenging, harsh environment. Salinity is in the range of 25% plus. वहां पे naturally occurring radioactive material होते हैं. Temperatures are very high or it can be very low or something. और आपको पता नहीं कि क्या काम चल रहा है because you are talking about acres and acres of land जहां पे आप अपना प्रोडक्ट डाल रहे हो. So it's a very challenging field. Swimming pool जैसा नहीं है बिल्कुल. आपको पता नहीं चलेगा क्या होगा. सो आप बोलोगे कि यार आप बोल रहे हो कि इसमें बहुत पैसा है, बायोलॉजी काम कर रहा है, अब बोल रहे हो बोलोगे इट्स नॉट इजी. तो समझ में आया कहना क्या चाहते हो? नहीं, मैं कहना चाहता हूँ कि इट्स डूएबल. So you will say, okay, how we will do it? So this is something work like this. So when you are into clinical trials or something, medicine में research करो, you need to go for phase studies, phase 1, phase 2, phase 3. Phase 3 is clinical trials, and उसके बाद आप data submit करोगे, and then you come up with a new product or something. Something similar we do in these kind of a thing. So phase 1 is lengthiest phase. आप माइक्रोब्स को आइसोलेट करोगे, उसको टेस्ट करोगे, आइडेंटिफाई करोगे, प्रोडक्ट्स बनाओगे, 2-4 PhD निकल जाएंगे इसके अंदर से, and then after everything is done, if you are lucky enough, you will have some good possible hypothesis in your hand. Then you will go for phase 2. You will go to oil company. So if you are lucky, they will say, okay, let's go for it. So then you need the help of software, simulations and models and everything. आप उनको बोलो कि मेरा प्रोडक्ट काम करेगा. आज तक कभी लाइफ में आपने वहां पे जाके काम नहीं किया है. They don't know, they don't trust biologists. Most of the senior people who are sitting there, they are very old and they are classical engineers or something. उनको माइक्रोबायोलॉजी बोलते हैं, वायरस याद आता है, अब तो कोविड याद आता है. When you go and say, सर मैं माइक्रोबायोलॉजिस्ट, बोलेंगे, oh very good, nice meeting you, फोटो लेंगे और बोलेंगे इधर से निकल जाओ. पक्का कुछ वायरस लेकर है, तो उनको इट्स वेरी बिग चैलेंज व्हेन यू गो विद अ डिफरेंट काइंड। कहने के लिए इंटरडिसिप्लिनरी अच्छा लगता है, बट इट इज वेरी बिग चैलेंज टू कन्विंस पीपल। So if they are convinced, you feed your data into their servers and softwares. We call it AI, ML, and all. So artificial intelligence will do all those analysis. They will give you the best possible scenario. तो आप उसको scale up करोगे और एक या दो oil field में आप उसको inject करोगे. Then you study for data for 6 months or something. You take it all TBs, terabytes of data and pentaflops of data. Again, put it into simulations and everything. And then if the machine says there is a high probability, and then you are really lucky, you go for phase three, and then you will become a billionaire and everything. So आई मीन मिडिल ऑफ 1 and 2 एंड एवरीथिंग। सो ज्यादा चीजें यहाँ पे खत्म हो जाती है। क्यों? क्योंकि जो पीएचडी करना आया है ना, उसको डिग्री मिल गई होती है, उसकी शादी हुई होती है और 2-4 बच्चे हो गए होते हैं, या तो कहीं पे नौकरी हो गई होता है और लड़की ढूंढ रहा होता है या लड़का ढूंढ रही होती है, एंड देन दैट्स इट, दे आर डन। 4-5 पेपर्स निकाल दिए, 2-4 कॉन्फ्रेंस में जाके आ गए, ऐसे खड़े होकर स्पीच दे दिया, एंड देन वी आर वेरी हैप्पी, वी आर सेटिस्फाइड पीपल। ग्रीडी नहीं है हम लोग, हम खुश हो जाते हैं छोटी छोटी चीजों में। सो वी स्टॉप हियर like in most of the products, but ऐसा नहीं है, you need to go for phase 2 and everything. So you will say आप कहाँ हो, बहुत ज्ञान मत दो। So again, 20 years of research in one slide. This is where we are. We isolated microbes and everything. We were lucky enough to have access to those places. We went there. We collected microbes. Microbes means आपको identify करना पड़ेगा. Why? Who knows if you are bringing something novel? So molecular biology use करो, chemistry use करो, physics use करो, engineering use करो, everything. When we find it, we produce the product. तो the calculation करना पड़ेगा. What if it's novel? Go for patent. Then you can own the right. You can sell it to other people. You can get the royalty. We did this. Then research. We don't want it to be in a paper or something. When you want to go to the market, scale up करना पड़ेगा. आपको ज़्यादा production करना पड़ेगा. Then only you can go to the market. So scale up into 100-liter bioreactors and everything. And now we are in discussion with oil companies and all. And simulation modeling also हो चुका है almost. So we may go to some oil fields or something. ये सब कुछ हुआ और मैं इंडिया में आ गया। अब ऑयल तो यहाँ पे है नहीं, ऑयल वहां है। सो इट्स अ स्ट्रगल, इट्स लाइक अ लॉन्ग डिस्टेंस रिलेशनशिप। तो यहाँ से अगर वो सेट हुआ, देन आई विल गो देयर एंड मे बी वन डे वी विल डू ऑयल रिकवरी। सो ऑयल रिकवरी कैसे करते हो? सो यू नीड एक्सेस टू सच सॉर्ट ऑफ इक्विपमेंट। मैं आपको अगर ऐसा बोलूं कि मेरी चीज काम कर रही है, तो आई नीड टू प्रूव इट ना, बिकॉज यू आर गोइंग टू गिव मी 10 करोड़, 20 करोड़, 100 करोड़, व्हाई विल यू गिव मी 10 रुपीज? So I need to prove it. So when we are into medical research, we go for animal models and everything. It's a different story. But when we are into oil recovery, मुझे oil reservoir में मेरी चीजें उस कंडीशन में काम करेगी, वो करना पड़ेगा। And they are not allowing me to go to the field. मेरे पास 500,000 लीटर बायोसर्फेक्टेंट है नहीं कि मैं oil field पे जाके करूँ। So I need to mimic oil reservoir in the lab. So मुझे ऐसे इक्विपमेंट की जरूरत पड़ेगी, इसको oil flood rig बोला जाता है। So before you go to the field, you do all the experiments here and you try to mimic everything which is happening in your reservoir. So you can have very high temperature, you can go up to 450 degrees centigrade plus. You can also go for a very high pressure, 2500 plus. Atmospheric pressure is 1 atmospheric pressure where we are all breathing. So oil reservoir will have a very high pressure. You can go for those pressure. You can keep on flooding your things and everything. So this is the kind of a rig where we do testing and we show them the results. They have access to the data, and if they are satisfied, then you go forward for it. So how did biosurfactant work? These are some of the core flood results for different biosurfactant, biopolymer. So some of the products are also working at very high salinity, 85 degrees centigrade plus temperature, either alone or in combination with chemical surfactants. Sometimes they are liking to work in a synergy. So you can replace part of the chemical surfactants and keep using your biosurfactants. So these are different data. So we managed to show around 5 to 50% plus additional oil recovery from the reservoirs and everything. It is working well. I said you can inject microbes or you can grow microbes inside the reservoir and still it will work. Biosurfactant banana nahi hai. What if microbes can produce biosurfactant inside the oil well? See, microbes are everywhere. They are atra tatra sarvatra, omnipresent. It's everywhere on our body, inside our body, and everything. So what if you devise a nice recipe and you give them the packet, the food in the reservoir, and then they will do the job there. तो अभी कैसा पता चलेगा? You need to work with these microbes. These microbes are extremophiles. They don't like to grow in presence of oxygen. So you need to work with anaerobic microbes. So these are some of the data. This is the rock. तो हमने उस microbes को food packets दिए, everything. We devised a recipe. We gave it to them. But the problem is there is a party going on. उसमें अच्छे microbes भी है और useless microbes भी है जिनकी आपको जरूरत नहीं है, which will create havoc. So the food जो वहाँ पे दे रहे हैं, it is distributed unequally. So chances of success are 50-50. It may or may not work, but it works well. So microbes are growing inside the reservoir. These are some of the ACM images of microbes. The one in the center is like a Martian rock, this image, and then the microbes are growing inside this rocks when we give them the food. It's also giving very good recovery of around 30% plus. enough of talking about making money. आप लोग बोले सर आप तो पैसा पैसा कर रहे हो. What about environment? अभी environment की दे रहे थे कि environment बचाना चाहिए. So of course many things are there, countless hours we can speak about. So we are not just working for making money for oil companies or something. हमने उनको बोला कि let's save the environment, and while doing so also you will save some money, because when you save environment ऐसे techniques use करोगे तो you will spend less money for whitewashing. So और भी बहुत सारे applications है. कुछ applications के बारे में देखेंगे. The first one is about improving the properties of the oil well, crude oil. How crude oil is produced, वो हमने देख लिया. वहां पे माइक्रोब्स कैसे करते हैं वो देख लिया. Oil produce हो गया. So oil कैसा आता है? It comes by various means from reservoir, Bombay High to here or something. It goes to refinery. So it has to be transported. उसके बहुत सारे challenges है, बहुत सारे environmental concerns है, and many things can go wrong. Like, so biggest challenge is when the oil is heavy. Heavy oil is shown in terms of API gravity or in terms of viscosity. बहुत ज़्यादा viscous होता है. It's like a chicken. बहुत ही viscous. Imagine you have 5 trillion barrels of oil at the oil reservoir और उसको transport करना at the refinery. It's like a thick tar. So कैसे करोगे? ऐसा नहीं कि वहां से फूंक मारा और हवा दे दिया तो it will come out there. It's possible with a light oil that you just pressurize it and it will come out. Refineries तक पहुंचाने के लिए it takes lot of time. तो कैसे करते हो आप? कितना पैसा लगता है when you want to do it. So there are three ways by which oil is transported. One is by trucks, by road transport they do it. It can be done by train if rail lines are accessible. They have it in a container, do it. Or else you can do it by pipeline. So by the time oil is produced, a lot of money is spent. And by the time oil is shipped from reservoir to your refinery, you are spending more money. So कौन सी चीज ज्यादा महंगी है? So on a rough estimate, it's very expensive to do it by truck. It's around $20 per barrel if you do it by roadways. If you do it by train, थोड़ा सा सस्ता होता है. But if you do it by pipeline, it's a fixed infrastructure. It's not going to be used for anything else. So it is much cheaper if you go it by pipeline. सेफ्टी कंपैरिजन, कितने लोग मरते हैं? ऑफ कोर्स बहुत ज्यादा डेंजरस चीज है. सो सबसे ज्यादा एक्सीडेंट्स होते हैं, इसके बारे में बोलने की जरूरत नहीं है. रोड. सो ऑन एन एवरेज अराउंड 102 10.2 10 और 20% कोई इंसान जो बच गया, हाथ पांव कट गया वोड़ो, तो 10.2 आई डोंट नो हाउ टू एक्सप्लेन इट. लास्ट टाइम कहीं पे देखा था तो किसी बच्चे ने बोला सर वो 10.2 लोग कैसे मरते हैं. तो मैं नहीं बोल रहा हूँ कि 10 और 20% किसी का आधा जमीन मर गया, ऐसा नहीं. इट्स एन एवरेज. सो यहाँ पे ऐसा दिखाना चाहते हैं कि ज्यादा लोग मरते हैं अगर बाय रोड करो. Accidents can happen by train also. So same thing. So lowest possible risky situation is by pipeline. The problem is pipeline में oil कैसे transport करोगे if it's very heavy. Different methods are available. Mighty chemistry. We use different processes. Chemistry is there to save your time and everything. But it's toxic, environment non-friendly. फिर biology वाले क्या करेंगे? तो हमने बोला I will give you better. You can do many things, but I will focus on one thing. So when you want to transport oil, you do immersion. You mix oil and water, so viscosity will be reduced, and it's cheaper and easier to transport instead of solvent. But when you want to mix it together, you can use chemical solvents or surfactant. So we say you can use biosurfactants. And once the oil comes to refinery, water and oil will get separated. So it's easier for you, and it's not toxic. So biodegradation का problem नहीं है. You need to prove everything. Theory में सब नहीं चलता है. So what we did, we took the heaviest possible oil. It's oil from one of the oil fields. It's very heavy. You can see viscosity is in the range of 1600 centipoise. So it's like a thick tar. And viscosity is shear rate dependent. So when you increase the shear, the viscosity will come down. So we did the combination of oil with our biosurfactant and everything, and we showed it to them. And then we need to do pipeline studies. लैब में आप सिर्फ उसको मिक्स करके ऐसे शेक इट करके दिखा नहीं सकते हो कि ये देखो कितना पतला हो गया. तो बोले वेरी गुड, चाय पिलाएगा और भगा देगा. क्योंकि उनको पतला देखने में इंटरेस्ट नहीं, उनको देखने की पैसा कितना बचाया. व्हाई शुड आई कम टू यू? मैं अपनी जेब से हाथ निकाल के तुम्हें पैसा क्यों दूं? So you need to do the economics. So what we showed them, that when we are doing this, the viscosity reduction is in the range of 97 to 100%. It becomes like water. Viscosity from around 114,000 centipoise or something comes back to zero. So it's like water, and then it gets separated. So it's all very good. Show it in the pipeline. So we have a rig, like core for a rig. You need to do experiments in the rig. So हमने pump pressure test किया, because पैसा कहाँ पे जाता है? For the pump efficiency. जितनी ज्यादा viscous चीज होगी उसको pump करने के लिए आपको ज्यादा energy चाहिए. So if it becomes less viscous, pump is going to save a lot of electricity, a lot of money. So we did these kind of experiments, and what we showed it to them, around 36% plus reduction was there in the pump cost. ये ground floor से first floor पे या fifth floor पे पानी पहुंचाने जितना cost नहीं है. When you say 36% of $5 million per year, it's a huge number. So they looked at this data, and this is quite good in terms of energy savings and everything when you use biosurfactant for reduction. Then we said about giving food to microbes. Oil में मैंने अगर food डाल दिया तो मैंने बोला कि कुछ कुछ notorious elements भी grow होंगे. This is one of the biggest problem. Sulfate reducing bacteria. It produces H2S. This is another reason. Before Corona came, oil engineers, petroleum engineers were never liking us, microbiologists. We should be thankful to this sulfate-reducing bacteria because it's a nightmarish microbe. क्या करता है? Problem क्या होता है? So 150, 140 years पहले जब से oil recovery start हुआ ना, तब से oil companies को ये problem आ रहा है. What is this problem? It's the production of hydrogen sulfide. हाइड्रोजन सल्फाइड है वो आपके ऑयल की क्वालिटी को खराब कर देगा. इट विल डू द सावरिंग ऑफ ऑयल वेल. जैसे दूध खट्टा हो जाता है ना, दूध फट जाता है और उसमें से दही बन जाता है. सो जैसा आपका दूध फटता है वैसे ऑयल रिजर्वोयर भी खराब हो जाता है बिकॉज ऑफ एसिडिक H2S. सो H2S जाके आपका पूरा रिजर्वोयर सावर कर देगा. इट्स नॉट गुड. दो टाइप का ऑयल होता है, वन इज स्वीट ऑयल, अदर इज द सावर ऑयल. अगर स्वीट ऑयल प्रोड्यूस कर रहे हो तो मार्केट में हायर कॉस्ट पे बेच सकते हो. इफ इट इज सावर इट इज एक्सपेंसिव. आपको उसमें से H2S निकालना पड़ेगा फिर भी बेच सकते हो. सो इट्स नॉट अ गुड थिंग फॉर ऑयल इंजीनियर. H2S इज अ कोरोसिव गैस. वो सारा पाइपलाइन सारी चीजों को करोड कर देगा. सो फ्रीक्वेंट मेंटेनेंस करना पड़ेगा. ऑयल स्पिल्स होगा, लीकेज होगा, नॉट गुड. उससे प्रॉब्लम नहीं है. पीपल विल डाई if the H2S is there. Working people in the oil reservoirs and everything, it's a very risky situation. So अगेन एल्सेवियर इज अ पब्लिशिंग हाउस. उन लोगों ने ऐसा एक पोस्टर बनाया था कि वर्क सेफ्टी प्रायोरिटाइज. और मैं इसको ऐसा लेता हूँ कि अगर आप ऑयल कंपनी में काम कर रहे हो तो किस किस तरह से मर सकते हो, कौन कौन सी अपॉर्चुनिटीज मिलेगी आपको ऊपर का टिकट काटने के लिए, विच इज द ट्रूथ. बट उन्होंने लिखा है कि आपको ये ध्यान रखना पड़ेगा वरना ये हो जाएगा. सो ऐसा समझाते हो तो लोगों को समझ में नहीं आता. सो वी नीड टू टेल देम इफ यू वांट डू इट. सो कैसे कैसे मर सकते हो अगर आप ऑयल इंडस्ट्री में काम कर रहे हो तो पैसा बाद में बनेगा अगर जिंदा रहोगे तो. सो ऊपर जो पिंक कलर का नाइस नाइस चीजें दिखाई है, that is about respirable silica sand. So when you are working in a desert or in a ocean, बॉम्बे की बात नहीं कर रहा हूँ, वहां तो समुद्र में डूब के मर जाओगे, तैरना आता है तो भी. So उसको बाद में डिस्कस करेंगे. If you are in a desert, mine nanosilica and everything. Nanosilica is a wonderful thing when you are working in nanomaterials or something. But oil field में जब कर रहे हो, drill कर रहे हो, so you will be breathing this nanosilica throughout your day. Lungs गए आपके, you will die with a cancer and everything. So respirable silica sand is a nightmare. लेट्स नॉट टॉक अबाउट व्हीकल एक्सीडेंट्स. यहाँ पे रोड पे एक्सीडेंट हो जाते हैं, लोग मर जाते हैं. वहां पे हेवी व्हीकल्स, टैंकर्स इन द डेजर्ट, आप मर गए तो एक वीक तक किसी को पता भी नहीं चलेगा कि वो बंदा आया क्यों नहीं है, घूमने चला गया. सो व्हीकल्स में ट्रांसपोर्ट में मरोगे. ऊपर जो चीजें दिखी हुई है, इट्स अबाउट फायर्स. ऑयल एक स्पार्क लगा और लोगों के बीच में स्पार्क हो तो मैजिक हो सकता है, वहां पे स्पार्क हुआ तो गड़बड़ हो जाएगी. वहां पे स्पार्क नहीं चाहिए हमको. अपने स्पार्क अपने पास रखो, स्पार्क्स को घर पर रख के आओ. वहां पे ऐसा लिखा नहीं होता है बट सब समझते हैं. कोई वहां पे स्पार्क नहीं दिखाता है. सो फायर के बारे में बात करने की जरूरत नहीं है. इफ यू आर वर्किंग इन अ रिफाइनरी, इट्स लाइक द सेफ्टी HSE हैज टू बी फॉलोड लाइक ए रिलीजन. आपको फॉलो करना पड़ेगा बिकॉज यू विल नॉट डाई. कंपनी को डुबाओगे, बहुत ज्यादा लोगों को मरोगे. वो सब अलग है. वी वांट टू टॉक अबाउट दिस नाइस ऑरेंज स्टार. Chemical exposures and H2S. This is one of the biggest challenge. अगर H2S exposed हो रहा तो मर जाओगे. So what is the danger? H2S is a sour gas, highly flammable. ऑक्सीजन से ज्यादा जल्दी आग इसमें लगती है. It's colorless. So H2S प्रोड्यूस होगा तो दिखेगा नहीं. And it is toxic at a very low concentration. कितने low concentration में? So it starts with, it's heavier than oil. उसको बहुत हाइट वाले लोग पसंद नहीं है. It stays in a low lying area. 6.5, 6.4 के नीचे वो सेटल हो जाती है. It's heavy. तो 6.5 से ऊपर के तो बहुत कम लोग हैं. ज्यादातर मेरे या मुझसे थोड़े छोटे नहीं बोल सकता, whatever. So we are like this, above average Indian height है. So we will be exposed. 6.5 वाले को प्रॉब्लम नहीं है और शायद ऊपर रहेगा. And oil companies reservoirs are all low lying area, pipelines and everything is there. So this is the area where gas will be accumulated. So low lying area में accumulate हो जाता है, दिखता नहीं है, it's colorless. स्मेल रोटन एग जैसी होगी. अगर जो अंडा खाता है, अगर अंडा खराब हो गया तो एक गंदी सी स्मेल आती है. इफ यू गो टू वेस्ट वाटर प्लांट और म्युनिसिपल वाटर प्लांट, गटर में से जो स्मेल आती है ना, लाइक वॉशरूम से ऐसी, दैट्स द स्मेल ऑफ इट. इट्स लाइक अ रोटन एग स्मेल. कब तक आती है? अप टू 10 ppm, which is 10 parts per million, 10 milligram per liter. If it goes to 100 ppm, it will affect your nerves. You will lose the sense of smell. अब वहां पे 100 ppm H2S है, बट आपको पता नहीं चलेगा कि वहां से लीकेज हो रहा है. If it is goes to 500 ppm, you will start vomiting. आप कोमा में आ जाओगे. If the concentration is 700 ppm plus, you will die with a single breath. इतनी आसान में हो तो शांत डेथ होगी कि आपको पता भी नहीं चलेगा. आप सूंघ रहे होगे और लोग आपको सूंघ रहे होंगे, फिर क्या हो गया? So, it's funny when I am speaking about it, but when you go to oil reservoirs, some of the oil reservoirs and oil fields have 50,000 ppm plus H2S. So you can imagine with 700 plus, Ram Nam Satya hai. So this is very big problem. And forget about fire and everything. So they have to take it religiously, and that's the reason they don't like microbiologists. वहाँ जाके बोलोगे मैं chemical engineering हूँ तो बोलेंगे आओ, मैं बोलूँगा microbiologist हूँ तो बोलेगा भगाओ. यही यही इंसान रिस्पॉन्सिबल है. एक्चुअली वी आर नॉट रिस्पॉन्सिबल बट हम माइक्रोबायोलॉजिस्ट है. सो दे डोंट लाइक H2S प्रोड्यूसिंग माइक्रोब्स. बहुत प्रॉब्लम होता है. ये सिर्फ इंसानों को नहीं मारेगा. दिस इज व्हाट यू आर सेइंग हियर. गाय भैंस, सो ऑयल वेल्स और वो सब वहां पे डेजर्ट में. सो इन मिडिल ईस्टर्न कंट्रीज दे आर लिविंग ऑन कैमल्स एंड एवरीथिंग. सो कैमल्स आर वंडरिंग हियर एंड देयर. तो एनिमल्स वहां पे जाएंगे एंड देन दे विल डाई. सिर्फ इंसान नहीं. 50,000 ppm इज टू मच. फायर का तो ध्यान रखना ही पड़ेगा. सो यू आर नॉट अलाउड टू वर्क and visit the site until unless you clear some exams. So I need to renew my license every 2 years. तो H2S का सर्टिफिकेट होता है. यूके बेस्ड कंपनी होती है. दे विल टेक योर थियरी प्रैक्टिकल एग्जाम, and once you clear with 99.9% score and above, means 100%, then only you are allowed to go and visit the place or collect the samples. And every 2 years you need to get this license renewed. और एक बार के लाइसेंसिंग की कॉस्ट होती है 2,500 pounds and above. So it's very risky thing. So we normally go in a buddy system. जैसे स्कूबा डाइविंग करने जाते हो ना, वो मास्क वास्क ऑक्सीजन लगा के. दिस इज हाउ यू डू इट. बट नॉर्मली वो इतना अच्छे से फॉलो करते हैं इन सब चीजों को कि एक्सीडेंट्स नहीं हो सकते. सो दे टेक केयर ऑफ द एरिया, दे कॉर्डन द एरिया. कोई रिजर्वर में ऑयल वेल में अगर H2S ज्यादा प्रोड्यूस हो रहा है, सो दे टेक केयर ऑफ इट. अगर वहां पे कोई आजू बाजू का एनिमल चला गया तो एनिमल ओनर्स विल फायर देम एंड एवरीथिंग. और अगर ऑयल वेल लाइक इन महसाणा एंड ऑल, इट्स इन द सेंटर ऑफ द प्लेस. सो आजू बाजू के खेती वाले लोगों को और सबको बहुत प्रॉब्लम होगा. हवा का रुख बदलेगा तो सिर्फ चीजें चेंज नहीं होती है, पीपल विल डाई. सो इट्स वेरी रिस्की थिंग. सो दे नीड टू पुट दीस काइंड ऑफ साइनेजेस एंड एवरीथिंग. तो जो कोने में बैठा हुआ उधर सब डरा रहा है. ठीक है, डरा नहीं रहा हूँ. मैं बोल रहा हूँ कि सॉल्यूशंस भी है हमारे पास. सो हम लोग क्या करते हैं, अगेन माइटी माइक्रोस. सो वी यूज टू वर्क विद ऑयल कंपनीज. जो पाइपलाइन वाला पिक्चर दिया है, सो सिर्फ क्रूड ऑयल में प्रॉब्लम नहीं होता है. नेचुरल गैस जो प्रोड्यूस होता है उसमें भी प्रॉब्लम होता है. सो नेचुरल, व्हेन यू ड्रिप इट, यू मे एंड अप गेटिंग नेचुरल गैस और यू मे एंड अप गेटिंग क्रूड ऑयल. तो अगर नेचुरल गैस प्रोड्यूस होता है उसको भी पाइपलाइन से ट्रांसफर करना पड़ता है. सो उसके साथ में सल्फर रिड्यूसिंग बैक्टीरिया, दे आर एनारोबिक, वो भी पास होंगे. सो व्हेन यू आर ट्रांसपोर्टिंग इट, इट विल करोड द नेचुरल गैस पाइपलाइंस. और एक ब्लैक पाउडर बनेगा विच इज द रस्ट. तो पाइपलाइन इज मेड अप ऑफ आयरन एंड एवरीथिंग. स्टेनलेस स्टील तो होता नहीं, इट्स वेरी एक्सपेंसिव. सो इट विल करोड द पाइपलाइन. सो उन सब चीजों पे भी काम किया है. So we have used chemistry and microbiology and everything to give solutions to oil companies. And we gave, so for this you need to go for metagenomics. आपको जैसे सैम्पलिंग के लिए जाता है ना कि बीमार पड़ गया तो डॉक्टर बोलता है सैंपल दे दो, ब्लड सैंपल, उसमें कल्चर करेंगे और ज्यादा पैसा. जैसे कोविड के टाइम पे RT-PCR करते थे. दे विल टेक योर नेजल स्वैब एंड दे विल सी द PCR अनकल्चरेबल माइक्रोब्स की तरह. सेम थिंग वी आर यूजिंग इट फॉर ऑयल फील्ड्स. सो इंस्टेड ऑफ अ पेशेंट वी गो टू ऑयल रिजर्वर, वी कलेक्ट सैंपल्स and we give them a Janma Kundli. It's like a Janma Patrika of the oil well. If the oil well is sweet, we tell them how much is the possibility of this oil well getting converted into sour oil well, और H2S प्रोड्यूस होने का कितना चांस है. और अगर ऑलरेडी काम तमाम हो चुका है, so we need to give them the recipe. So we did some experiments and we give them the packets of nutrients and something else. So there is a competition in the oil well. So SRBs ही नहीं होते, नाइट्रेट रिड्यूसिंग बैक्टीरिया भी होता है आपके ऑयल फील्ड में, and they don't like each other. भारत पाकिस्तान जैसी चीज है. So what if I can increase the population of NRB? तो SRB मर नहीं जाएगा, बट SRB के पास खाने के लिए फूड नहीं रहेगा. So I will use some food by which NRB population can be increased. So you do these kind of experiments, you dump it into your oil reservoir और उसका रिजल्ट चेक करोगे मोलिकुलर बायोलॉजी से. So कुछ दो oil wells का रिजल्ट है जहाँ पे आफ्टर एंड बिफोर का सिनेरियो दिया हुआ है. So the population of NRB increased and equivalently when we check the H2S production and everything, it was come down. So ये भी कर सकते हैं. So you have learned about producing oil. You have seen about saving some money. ये सबके साथ में क्या होता है कि there is a biggest problem to oil companies is produce water. What is produce water? So to produce oil, you need to inject water with or without chemicals, with or without microbes or anything. So when you produce it, oil मिल जाएगा. What to do with this water? तो वो जो water बाहर आएगा, it's a nightmare. उसके अलावा और भी बहुत सारे प्रॉब्लम्स होंगे. कौन सा प्रॉब्लम है? सो टू प्रॉब्लम्स आर. वन इज द स्केल, कितना पानी आता है, और दूसरा उसमें क्या क्या है. सो ऑयल एंड गैस इंडस्ट्री का सबसे बड़ा प्रॉब्लम ये है, दे नीड ह्यूज क्वांटिटी ऑफ वाटर. विदाउट वाटर दे कैन प्रोड्यूस ऑयल. एंड नाउ द प्रॉब्लम इज व्हेन वाटर कम्स आउट, इसका ट्रीटमेंट क्या करना है. वी आर नॉट टॉकिंग अबाउट 10,000 लीटर और समथिंग. व्हेन यू लुक ऑन दिस साइड, it's the quantity we are talking about. It's in terms of cubic meter. So it's a published data कि US, Australia, China, India per day. So when you look at the company, we were working in Oman. So we were producing 900,000 cubic meter of water per day. So the problem is when you produce oil, ऑयल वाटर का रेशियो में ऐसा होता है कि पर बैरल ऑफ ऑयल व्हाट यू प्रोड्यूस यू एंड अप प्रोड्यूसिंग 9 बैरल ऑफ प्रोड्यूस वाटर। बैरल इज अराउंड 159 लीटर और समथिंग। सो एक बैरल ऑयल के लिए आपको 9 बैरल जितना वाटर यूज करना पड़ता है। सो ऑयल तो मार्केट में बेच दोगे, इस वाटर का क्या करोगे? अब पानी का प्रॉब्लम क्या है? मोस्ट ऑफ द ऑयल प्रोड्यूसिंग कंट्रीज वाटर इज नॉट देयर। वहां पे बारिश ही इतनी कम हो रही है, हर जगह का प्रॉब्लम है, तो पीने का पानी नहीं है, तो ऑयल प्रोड्यूस करने का पानी का क्या करोगे? सो हैविंग एक्सेस टू वाटर इज अ प्रॉब्लम। Second thing, this water is a nightmare of any water treatment companies. It's a nightmarish commodity. उसके अंदर बहुत ज्यादा वॉल्यूम होगा, वॉल्यूम तो हमने देख लिया, इट्स ह्यूमंगस वाटर पर डे। उसके अंदर ऐसा सब कुछ होगा जो नहीं होना चाहिए, वेरी हाई सैलिनिटी, रेडियो एक्टिव मटेरियल, केमिकल्स, जो केमिकल्स 50 साल से 100 साल से डाले जा रहे हो, H2S प्रोड्यूसिंग माइक्रोब्स, क्रूड ऑयल, ट्रेसेस ऑफ टॉक्सिक केमिकल्स एंड एवरीथिंग। सो इट्स अ वेरी यूजलेस कमोडिटी व्हाट वी हैव टू ट्रीट। सो उसको पब्लिक क्या करती है, थोड़ा बहुत ईओआर के लिए यूज करते हैं, एनहांस ऑयल रिकवरी, या तो उसको रीयूज करने के लिए डाल देते हैं, या तो उसको डीप वेल डिस्पोजल करते हैं। व्हाट इज इट? पानी बोरवेल बोरवेल बनाते हो घर पे निकालने के लिए, तो उसमें से पानी निकालने के लिए लेते हो। वंस इट्स नॉट वर्किंग, दिस गाइस दे विल डंप इट बैक इनटू द रिजर्वोयर। इसके काफी सारे चैलेंजेस है। इट्स एन एनर्जी इंटेंसिव प्रोसेस। पानी प्रोड्यूस नहीं करना है, पानी को अंदर डंप करना है, एंड ह्यूज क्वांटिटी ऑफ वाटर, 900,000 क्यूबिक मीटर इज इन 900,000 into 1,000। सो इट्स अ ह्यूज क्वांटिटी पर डे। उसको कहीं डिस्पोज करना है, फेंकना है। पहले लोग फेंक देते थे, ऐसा होता ना कि अपने घर का कचरा निकाल के बाजू वाले के घर में डालेंगे। उसको पता नहीं कि बाजू वाला पहले अपने घर में कचरा डाल चुका है, तो अपना घर तो हमेशा गंदा ही रहेगा। दिस इज व्हाट गाइस यूज्ड टू डू बिफोर ईपीए एंड ऑल दोस थिंग्स। इंस्टाग्राम और ये सब आया नहीं था ना, तो लोग ये करके आंख बंद करो और समुद्र में डाल दो, या तो डाल दो कहीं पे भी। अब वो इतना एक्यूमुलेट हो गया है कि अब छुपा नहीं सकते हो, बिकॉज इट्स ह्यूज क्वांटिटी। सो नाउ दे आर आंसरेबल, उनको पैसा डालना पड़ेगा, टेक्नोलॉजी में पैसा डालना पड़ेगा। सो दे आर नॉट लाइकिंग दिस, इस पर बहुत इन्वेस्टमेंट करना पड़ेगा। सो दे आर डूइंग रिसर्च। सो वी आर गिविंग वेस्ट टू वाटर प्रोग्राम टू दीज काइंड ऑफ कंपनीज एंड एवरीथिंग। We go to nanotechnology. If you are into दो टाइप की osmosis होते हैं, one is reverse osmosis or else you can go for forward osmosis. So reverse osmosis is what के पानी के लिए और उन सब चीजों के लिए हम यूज करते हैं। आरओ वाटर बहुत ज्यादा वाटर वेस्ट होता है, मेम्ब्रेन से कट ऑफ होता है और पीने का पानी मिलता है। इन फॉरवर्ड ऑस्मोसिस वी हैव अ मेम्ब्रेन एंड बेस्ड ऑन द टेम्परेचर ग्रेडियंट नैनो मटेरियल से उसको मॉडिफाई करता है। इट इज एक्सपेंसिव प्रोसेस, तो अगर आपके पास पैसा है तो यू गो फॉर नैनोटेक or else we go for water treatment by algae. So we grow algae, it will do the bioremediation, and you can use the water based on the quantity. Algae, why algae? ये हमें ऑयल कंपनीज को बोलना पड़ता था, आप लोगों को पता है। सिंपलेस्ट माइक्रोब, इट फिक्सेस CO2, इट नीड सनलाइट, और बाकी खाना जो उसको कंप्लेंट नहीं करता, इट टेक्स केयर ऑफ द जॉब। डिफरेंट डिफरेंट काइंड्स ऑफ फ्रेश वाटर मराइन एल्गीज आते हैं। डुनिया सलेना इज वन ऑफ द स्पीशीज। सो काफी सारे हमने वहां से algae ऐसे आइसोलेट किए थे फ्रॉम ऑयल फिल्स एंड एवरीथिंग, जो 25% प्लस ऑयल एक्यूमुलेट कर रहा था और वाटर ट्रीटमेंट भी करता है, और मिक्स क्वांटिटी ऑफ ऑयल में यूज होता था। मार्केट, I like to talk about market. So we don't want to give them the treatment for water. When you are working with algae, algae is used for many things. अलग-अलग market है. Market is in the range of around 11 billion dollars to around 1.8 trillion. It's an old data. आप उसको use कर सकते हैं nutraceuticals. You can use it in cosmetic industry, biofuels and everything. बायोफ्यूल्स वाली और वो सब चीजों पे हम बात करेंगे। सो आप algae ग्रो करते हैं, उसमें से पैसा बनाओगे। What to do with the treated water? This is a luxury. आपके पास सडनली इतना सारा पानी आ गया है जहाँ पे बारिश ही नहीं हो रही है, सो यू कैन यूज इट फॉर एग्रीकल्चर। आपको पीने लायक नहीं होगा, अनलाइक इफ यू गो फॉर नैनोटेक, इट्स नॉट वाटर फिट फॉर कंजम्पशन और समथिंग, बट पानी है ही नहीं वहां पे। सो दे डिड सम एक्सपेरिमेंट्स इन एग्रीकल्चर एरेबल लैंड्स और उन सब में। जेट्रोफा से स्टार्ट किया था उन्होंने, बिकॉज इट हैज सेवरल एप्लीकेशंस। उसको बायोफ्यूल बना सकते हो, उसमें से काफी सारे आयुर्वेदिक जैसा एप्लीकेशन होता है, सो मेनी थिंग्स। जेट्रोफा विल नो इट वेरी वेल। और उसको ग्रो होने के लिए बहुत पानी नहीं चाहिए, एक्चुअली इट ग्रोज इन एरिड लैंड। नाउ दे आर वर्किंग विथ कॉटन प्लांट एंड एवरीथिंग। पैसा अगेन उनको, सो जेट्रोफा से उतना पैसा नहीं बन रहा है। So we are working on some sort of species or something like cottons and all they are growing there. So you can use the treated water for agriculture. So this is oil field produce water treatment solution we gave to oil companies, and it's in the next phase. So last वाला जो पीछे वाले बोर हो गया। So आप बोलो सब बराबर है सर, अब ओमान में नहीं हो, इंडिया के बारे में बात करो। अब आपके पास ऑयल वेल नहीं है। So it can be used for better applications also. It's for natural gas hydrant and CCS. जो लोग न्यूज देखते हैं या नहीं देखते हैं, रील्स देखते हैं, ये देखा होगा ना, हमारे वित्त मंत्री फाइनेंस मिनिस्टर निर्मला सीतारामन जी ने ये बोला था 10,000 करोड़ उन्होंने फार्मास्यूटिकल्स और उन सब के लिए डाला है, बायोसिमिलर्स एंड एवरीथिंग। बायोसिमिलर इज अ काइंड ऑफ अ ड्रग जिसका पेटेंट एक्सपायर होने आया है, एक्सपायर हो गया है, और आप उसको फ्री में बना सकते हो। पेटेंट लाइफ इज अराउंड 25 years और समथिंग। be it antiviral drug, anti-cancer drug, whatever. So 10,000 crore government of India ने 5 साल के उसमें दिया है. They have given 20,000 crores for this sector. What is that? देखा है किसी ने बजट सर हमारा बजट तो हमारे पापा मैनेज करते हैं, मम्मी मैनेज करती है, वो तो है, उसके बारे में नहीं पूछ रहा हूँ मैंने कितना खर्चा कर रहे हो, बट बजट देखा होगा ना, एनुअल फाइनेंशियल बजट. सो गवर्नमेंट हैज एलोकेटेड 20,000. इट्स अ ह्यूज अमाउंट फॉर द कोर्स ऑफ 5 years. इट्स गिवन फॉर कार्बन कैप्चर, यूटिलाइजेशन, स्टोरेज. बहुत ज्यादा CO2 का इश्यू हो रहा है. सो दे वांट टू सपोर्ट यू. अगर आपके पास कुछ आइडिया तो दे वांट टू सपोर्ट यू. सो दिस इज वेयर द इन्वेस्टमेंट इज नीडेड. इसमें हम लोग कहाँ पिक्चर में आते हैं. सो वी आर वर्किंग ऑन नेचुरल गैस हाइड्रेट. व्हाट इज NGH? Chemistry, if you look at the picture, it's a crystalline compound in the lattice of your water molecule. So जो red वाला part है, it's a water molecule. उसके cage में gases can be stored. If the temperature is very low, it will become ice formation. So you can trap CO2, methane, and everything in the ice. Not we can. This is how it is done throughout the ages. जैसे crude oil store हुआ है, वैसे gas hydrates are also stored in your reservoir at a very low temperature. So how is the advantage? You can have CO2, you can have different gases into it. So this is how the picture looks like. It's a real natural gas hydrate made in the lab. So when you take this ice and if you put fire to it, it will burn in your hand. तो आपको हाथ नहीं जलेगा. जो भी मीथेन and water molecules were trapped है, you can release it. It will be used as a fire, and what will be left is water on your hand. So this is natural gas hydrate. So उसके बहुत सारे gases है, मीथेन, ईथेन and everything. अलग-अलग world के different area में इसके stores है. Huge deposits are available. So what we want to do, we want to explore it now. If you don't have oil, you want to explore these kind of hydrates and everything. जिसमें से मीथेन का untapped source ले सकते हो. So chemistry is wonderful here. So what you can do, if you inject CO2 into methane hydrates, तो मीथेन रिलीज हो जाएगा और CO2 वहां पे ट्रैप हो जाएगा. So 20,000 crore क्यों दिया है गवर्नमेंट ने? To work on something like this, that you can trap CO2. It will be nicer icing on the cake कि अगर आपने CO2 ट्रैप कर दिया और एनर्जी रिलीज कर दी. It's a renewable kind of energy. Crude oil नहीं है. And we have huge deposits of methane gas hydrates in Arabic Ocean, Indian Ocean and everywhere. रशिया में है, चाइना में है, मिडिल ईस्टर्न कंट्रीज में मीथेन गैस हाइड्रेट्स नहीं है. We have it. So different groups are working on in IIT चेन्नई में काम कर रहे हैं, गुवाहाटी में काम कर रहे हैं, पेट्रोलियम डेवलपमेंट रिसर्च है, अलग अलग जगह पे पैकेट्स में इंडिया में भी हम रिसर्च कर रहे हैं इन सब चीजों को. सो अगेन क्रूड ऑयल्स बनने में मिलियंस ऑफ ईयर्स लगे, तो नेचुरल गैस हाइड्रेट बनने में भी मिलियंस नहीं लगते. वी कैन डू इट, बट इट टेक्स टाइम. इट्स एन एनर्जी इंटेंसिव प्रोसेस. तो कैसे करते हो? सो यू नीड प्रमोटर्स. ऐसे अपने कंपनीज में और उन सब में भी प्रमोटर्स होते हैं जो प्रमोट करते हैं either with money or with a word of mouth or something. So it makes it easy for you whether you're in a business or something. So you can have different kinds of promoters here. So chemical surfactants are very good when you want to synthesize and you can fasten the process. We don't have a lifetime. We have 80 minutes, almost done. So जैसे यहाँ पे 80 minutes से 90 minutes है लैब में, या हमको अगर CO2 स्टोर करना है तो we don't want to wait for a strong process. So we normally use chemical surfactants. And again, हमने बोला chemical surfactants क्या कर रहे हो इस जमाने में? We have a better solutions for you. Let's go for bio-based solutions. तो करके दिखाओ. So biosurfactants, we are working with these kind of molecules with CSIRO in Australia, in China, in Singapore, of course in India also, and we are supplying them biosurfactants. और उसके ऊपर काम चल रहा है. So when you use biosurfactants, even when you use amino acids, different kinds of, you can Google it. Plenty of work is going on in these things. So when you use amino acids or plant-based product, it will help you in storing CO2 and releasing methanes and fastening the process of gas hydrates. बच्चे बोर हो गए, बोले एंड पे आओ. So where is the problem? सब कुछ बराबर है. 150 पेपर छाप दिए, पेटेंट्स ले लिए, $5.5 million का फंड मिल गया, बाल गिर गए, चश्मे आ गए. So अभी कहाँ हो सर? कंपनी क्या करे आपकी? कंपनी कुछ नहीं कर रही है. कंपनी अंडर द प्रोसेस. दिस इज द प्रॉब्लम. एलिफेंट इन द रूम इज कुछ भी करो, केमिकल प्रोडक्ट्स आर स्टिल चीपर देन बायो प्रोडक्ट्स. कांट हेल्प इट. एनवायरमेंट बाद में आता है, पहले पैसा बनाने की बात आती है. बिजनेस चलेगा तो काम चलेगा. सो बिगेस्ट प्रॉब्लम इज दिस. Bio-based products are still not so well with chemical products. That's a problem. This is me. ये पेपर बने थोड़ा छोटा सा था. 20 साल 30 साल रिसर्च किया, ग्रांट्स मिल गया, पेपर पब्लिश कर दिया. कंपनीज के पास गया तो बोलते कितने में, पूछते कितना देती है एवरेज. वी इंडियंस आज माइलेज कितना देती है, तो कितने में बेचोगे? बोला सर $100 में. तो बोलते हैं हंसने लगा, बोले इसको नाश्ता कराओ, बाहर लेके जाओ. तो क्या हो गया सर? बोले नहीं कॉफी पियो, इट्स वेरी गुड, आई लाइक इट. तो फिर बाहर जाने के बाद पता चला वो $1 में मिल रहा है केमिकल प्रोडक्ट जो पर केजी. सो केमिकल पॉलीमर्स, केमिकल सर्फेक्टेंट्स आर रियली चीप. Nanoparticles are expensive, but bio-based products are not so cheap. So of course we are working on it. We developed our technology, we have done scale-ups and everything. So now it's not cheaper, at least at par. But the benefits are outweighing it. So governments are forcing them to use slightly expensive ring also. So we have a scope here. So of course, publications and all, we need to work on it. This is my lab. We have 50-liter bioreactor apart from many things. So our students are working on it, and we are actively working on anything and everything where it says microbial technology. Work under progress is this. It's a map of Oman, oil lines, oil pipelines, reservoirs, and everything. So we are working on some project, pilot trial. One pilot, it's a part phase two, what you have seen there. We have done it and everything. So we will data AIML और सब चल रहा है. If it goes well, we may go and we'll apply it in the oil field or something there and elsewhere. So our group is working on, of course, enhanced oil recovery, chemicals, bioproducts, and everything. We are working on crude oil transport, in soaring of oil wells and natural gas hydrates and everything. Biofuels, microbial products. We are working on antimicrobial resistance and many things. Microbiology is very near to my heart and everything. Worked in industries and everything. So anti-cancer drugs और उन सब पे भी काम चल रहा है. So just to summarize what we have seen here, there is a lot of potential environmentally as well as monetary also, and a lot of work can be done by biologists, but some challenges are there which we need to work on. Geopolitical and economic scenario, when the crude oil prices were low, prices काफी कम हो गए थे ना. जैसे कोरोना आया तो लोगों को माइक्रोबायोलॉजी बायोटेक की वैल्यू पता चली, वैक्सीन क्या है पता चला. बाकी तब तक दे वर टेकिंग अस फॉर ग्रांटेड. हाँ ठीक है, वैक्सीन मिल रहा है, एंटीबायोटिक्स बना रहे हैं, चाइना से आ रहा है. When the time came and we proved to the society that we are needed, we are very much in need. So उनको पता चला, now a lot of fund is given for AMR and everything. So oil prices जब high होते हैं, they want to do research. Otherwise, it's a problem. Change of mindset. They are not biologists. They are worried of COVID. नया आ गया. They were worried of SRB. So they don't like microbiology and expenses and everything. So change of mindset is a problem. But still, it's a multi-million dollar industry. Scope for all of us. So take home message for you and me would be, of course, we are looking forward for safer, better environment and everything, where renewables will play a bigger role, like natural gas hydrates, hydrogen, methane, biofuel or something. But at the same time, we don't want quick reactions and then ending up in trouble. कल से कोई गाड़ी use नहीं करेगा. It become a nightmare. Not possible. Can't do it. So challenges are there, but at least in my lifetime, and by the time you will reach to my age, 40-50 तक आओगे, will be very much using crude oil, fossil fuels, and everything. Renewables will be playing a bigger part, but it will be like a synergy and everything. So in a longer run, we are looking forward for a solution. We don't have oil. ऐसा बोलना पड़ेगा मुझे, क्योंकि यहाँ पे oil नहीं है. तो Indians को तो बोलना पड़ेगा. We vote for renewables. Oil ही नहीं है. Can't help much. But जो लोग oil produce कर रहे हैं उनके लिए भी challenge है. Only those countries will survive जो उसको कम पैसे में produce कर सके और updates ले सके अपना. They have to integrate renewables and everything into it. Only those countries will manage. So of course, thanks to funders, university, AUR, अलग-अलग funding agency, team members from Oman, India, University of Ulster, Kyushu, Japan, Calgary, Canada, Kazan Federal University, Russia, RJAPT, Ametkewala, and then SNF for giving the polymer, UPS in India, Schlumberger for access to softwares and heavy duty servers and simulation models and everything. And of course, students, 40 से ज़्यादा नाम नहीं डाल सकता हूँ, यहाँ पे दिखेगा नहीं सबका. Of course, students are playing a very big role. We don't have time. Meetings करते रहते हैं, plan बनाते हैं, but students are the workforce. So of course, thanks to them, big thanks to them. उनके अलावा यहाँ पे आकर बात नहीं कर सकता था. And thank you. This is Amit University, Rajasthan. It looks like a resort in middle of a desert. पीछे जो दिख रहा है जैसे अरावली foothills. Topic of a different day. अरावली का जो problem चल रहा है, it's in the foothills of Aravali, and we have an artificial lake and everything. So thank you very much. जयपुर आओ तो फोन कर देना. Thank you. We have water, water is all beside underground water. So have very cheap bacteria which can treat underground water, because we have a sample where color is like 5,000 plus, pH is very low, all kind of metal you will find. There's chromium, selenium, anything. So do we have such kind of bacteria on a very cheap rate to treat this water? वेरी गुड क्वेश्चन। सर पूछ रहे हैं कि ऐसा कुछ बैक्टीरिया है हमारे पास, मैजिक पिल है जो which can treat almost anything or few of the things or something. Bacteria है, so it's not a problem. But the thing is, we are unable to replicate it in a bigger scale because the scale of pollution is too big. हम अपने घर में एक टेबलेट डाल के, क्लोरीन का टेबलेट डाल के, या तो स्विमिंग पूल में थोड़ा सा क्लोरिनेशन करके नहीं बात कर रहे हैं. The amount of pollution we have done is too much. It's beyond us to repair or beyond nature to repair or something. So microbes है, but it works in a synergy, consortium चाहिए होगा. Single microbe ऐसा कोई है नहीं जो ये सब कुछ कर पाए. अगर है तो ऐसा किसी ने पब्लिश नहीं किया, because those things they want to make money, they don't want to publish it. इंडस्ट्री में कोई पब्लिश नहीं करना चाहता, जो सर भी कल बोल रहे थे, पेपर्स नहीं चाहिए, they want to publish, they want to print different kind of paper. उनको पैसा छापना है, उनको वहाँ पे पेपर नहीं छापना है. So they don't want, it's all confidential and everything. वो बताना नहीं चाहते. So even if it is there, it's not accessible to us, the common people. एंड ऐसा कोई एक माइक्रोब नहीं है कि जो ये सब कुछ कर पाए, जो हर तरह का पोल्यूशन ट्रीटमेंट दे पाए. अगर हमारा हैवी मेटल का इश्यू है तो अगेन देयर इज नो सिंगल माइक्रोब व्हिच विल टेकल द सॉल्यूशन ऑफ आर्सेनिक, प्रॉब्लम ऑफ माइक्रोप्लास्टिक्स एंड एवरीथिंग. तो ऐसा अभी तो है नहीं. एंड इवन इफ इट इज देयर, हमें पता नहीं कि वो कैसे कर रहा है, बिकॉज वी वांट टू रेप्लिकेट इट. वी वांट टू यूज ग्रीन केमिस्ट्री. लाइक माइक्रोब्स को ग्रो करने के लिए बहुत सारे प्रॉब्लम्स है. हमें स्टेरिलिटी मेंटेन करनी पड़ती है. माइक्रोब्स आर लाइक मूडी फ्रेंड्स. उनका मूड चेंज हो जाएगा. आज काम करे, कल बोलेंगे आज नहीं करूंगा, आज मेरा मूड नहीं है, उठेगा ही नहीं. अपना दोस्त जो आने वाला था. इट्स लाइक दिस. सो इट्स अ लिविंग सिस्टम. सो देयर आर सेवन चैलेंजेस फॉर माइक्रोब्स. सो दैट्स व्हाई द केमिस्ट्री इज ऑलवेज देयर फॉर यू. तो हमें पता चले ना कि वो मॉलिक्यूल क्या है, वी विल डू इट इन द लैब. वी विल सिंथेसाइज इट बाय सिंथेटिक केमिस्ट्री और समथिंग. बट वो जो लिंक है ना, वो हमारे पास नहीं है अभी. इंस्टिल वी आर. दिक्कत ये है कि मैं अगर दिन में 1,000 रुपया खर्च करता हूँ ना, लेकिन कमा तो 100 ही रुपया रहा हूँ, वैसा हो गया. सो आई एम हैविंग 1,000 प्रॉब्लम्स एंड आई एम क्रिएटिंग 10,000 ऑन डेली बेसिस. उसमें से मुझे 10 प्रॉब्लम सॉल्व करने का भी टाइम नहीं मिलता है 24 आवर्स में. सो वी आर डूम्ड सर. नहीं, हम लोग सोल्यूशन निकालेंगे. इतने सारे यंग लोग यहाँ पे, वी विल हैव सम सॉल्यूशन. बट एज ऑफ नाउ ऐसा अगर है तो हमें पता नहीं है, और मुश्किल है. इट्स अ बिग चैलेंज. तो अगर ऐसा कुछ निकाल के लेके आ सकते हैं तो डेफिनेटली इट्स पॉसिबल. स्केल अप इज बिगेस्ट चैलेंज सर. स्केल अप के लिए पैसा चाहिए बहुत ज्यादा. तो दे डोंट वांट टू गिव मनी टू यू. आप मुझे बताओ कितने एंटीबायोटिक्स पिछले 10 साल में नए निकले. इट्स नॉट अ गुड बिजनेस, बिकॉज डायबिटीज इज वेरी गुड, कैंसर इज वेरी गुड एज एन इंडस्ट्रियल पर्सन. क्योंकि जितने ज्यादा लोगों को कैंसर होगा, दे विल बाय माई मेडिसिन. कितने लोग कॉमन कोल्ड के लिए आते हो, कितने में बिकता है? 50 रुपीज पर स्ट्रिप, 100 रुपीज पर स्ट्रिप. कैंसर का डोज ज्यादा में जाता है. बीपी हो गया, वेरी गुड. Okay, not good for you, but because VP Aga, you have to come to my company. So I want to invest into research where I can make money out of it. Antibiotics का problem हो रहा है. So the problem is we should invest into antimicrobial agents or something, but there is no money. It takes so much money, so much years. Like 15 साल बाद एक एंटीबायोटिक निकलता है, 500 करोड़ खर्च हो गया होता है. मार्केट में कितने में बेचेगा? आत्मनिर्भर भारत में 10 रुपए में स्ट्रिप. So where is the return? So as an entrepreneur, I don't see money in it. So they are not interested. Answer is good. पैसा बचाओ, it's an expensive thing. So scale up is a challenge, and for scale up and going to mass market, we need money. So this is where government comes into the picture. Government should support it. किसको? TRL fee से नीचे के research को, because something will come out from people like you and me, from the students. But funding is very difficult. वो लोग बोलते हैं कि output कितना है, कितना पैसा मिलेगा, कितना होगा. So it has become business now. So गए सर हम लोग. Sorry for the bad news. But there is a lot of opportunity. This is the place where you and we come into the picture. हम ही लोग सॉल्यूशन निकाल के लाएंगे हमारे जैसा ही कोई. मैडम पूछ रहे हैं कि आपने बता दिया कि एसआरबी को मारना है तो एनआरबीज को एनकरेज करो. ऐसा नहीं कि अगर एक चूहा निकल गया, हाथी घुस गया. नहीं, ऐसा नहीं होता है. सो एनआरबीज आर नाइट्रेट रिड्यूसिंग बैक्टीरिया. इट विल रिड्यूस द नाइट्रेट एंड it's not so much problematic like SRBs. No, we don't only go for this. There are several things. This is the last thing what we do. We offered them this. What they do? आप बीमार पड़ते हो तो क्या करते हो? कल एक अर्जेंट मीटिंग है, या तो कल आपका एग्जाम है, यू आर हैविंग हेवी फीवर. सो वी गो फॉर सिम्प्टोमेटिक रिलीफ, which is like I will go have a crossing. बुखार कम हो जाता है? नहीं, कम नहीं होता है. You are unable to see it. What it does is it will, you will perspire, perspiration होगा और ऐसा लगेगा कि बुखार कम हो गया, but you are still sick. So we want quick solution. So same thing they do in oil field. वो बोलेंगे इसको हटाओ SRP को. नेक्स्ट बैच में SRP दिखना नहीं चाहिए, H2S आना नहीं चाहिए एनालिसिस में. तो हम क्या करते हैं? We feed something which kills microbes. So we use biocide. What is biocide? It's like treatment of tuberculosis. TB का पता है ना, Mycobacterium tuberculosis. The problem is it's so resistant microbe, it mutates so fast कि आप उसको एक मेडिसिन से मार नहीं सकते हो. So you need DOTS, DOTS. It's a treatment what we give them. So last third generation जो भी antibiotics है, we use in a combination of three. So अलग अलग combination में उसको देते हैं. Now what is the problem? It is resistant to that also. Same thing is happening in the oil field. So we go for very heavy carcinogenic, toxic antimicrobial agents. It's called as a biocide. सुनने में अच्छा लगता है. It's toxic compound, corrosive and everything. So we just inject it there and it kills 99.5% microbes. What about 0.5? So those are the resistant ones. So next time when I go for a treatment of biocide of my oil reservoir, these antimicrobial agents, it won't work. And we are not talking about treating one patient. We are talking about 10 acre, 100 acres of land. तो पता नहीं वो medicine कहाँ जा रहा है. मैं तो खा रहा हूँ तो at least वो मेरे अंदर जा रहा है, patients में effect दिख रहे हैं. So we always prefer biocide as an oil engineer. तो हमने बोला it's not working out. But the problem is when you use biocide, you are killing good microbes also. Maybe it is producing biosurfactant, maybe it is producing biopolymer, maybe NRBs are there. So NRBs भी मर जाएंगे. So when we do oil fill analysis, we find struggle a lot क्योंकि वो जो chemicals use करे it is toxic. So SRV survive हो जाएगा, ये सब survive नहीं होता है. So we want to give food to these kind of microbes जो थोड़ा competition देंगे and increase the population. So NRBs won't produce nitrous oxide and everything, but it reduces nitrate. Nitrate reducing bacteria is used in biofertilizer also. You use it for nitrogen fixation bacteria, rhizobium and everything. It's not rhizobium, but something similar. So when the healthy population probiotics खाते हैं ना, when we take antibiotics, it gives doctor prescribes us probiotics and vitamins and everything. Because when you take antibiotic, like killing microbes in oil reservoir, we kill our gut flora also. तो मुंह में छाले आ जाएंगे, खाना नहीं खाओगे. It takes time to rebuild your gut flora. So we take probiotics. So we can't give probiotics to oil well. We give food where these microbes will grow better. तो फायदा नहीं होगा लेकिन H2S प्रोड्यूस होना बंद हो जाएगा. That itself is a big benefit. So it's not problematic. NRBs are nice guys. Anaerobic but good. H2S, hydrogen sulfide. It's water soluble, it's oil soluble gas, and it's an acidic gas. So H2S बनेगा तो H2SO बन जाएगा सीधा. It is a competition. Methanogens are even slow grower. SRB grows faster. It needs acetate and some sulfide. So SRBs को sulfide कहाँ से मिलता है? From the geology. जो भी आपके minerals है, because it's a reservoir. So sulfur is already there. Plus they need acetates and or simple organic acid. So when you flood it with oil, production के लिए जब oil flood करते हैं, तो some salts and some acetates comes with the water. So they grow it there. Methanogens are very slow grower. They are very slow. ये गुंडे हैं. ये सब खा लेते हैं. No, SRBs will give a problem, not methanogens. So you can work with methanogens also, you can increase the population, but they're very slow grower. NRB grows faster than SRBs or faster than methanogens. So when we do metagenomic screening, we screen everything. Methanogens, acid producing bacteria, normal bacteria which is not doing much harm, but whichever grows faster without doing much harm, you want to do other population. But those SRBs, they are very simple. उनको सल्फर मिल जाए और हल्का सा एसिटिक एसिड या एसिडेट मिल जाए, they will do the damage. They will produce H2S. So SOB भी use करते हैं, sulfur oxidizing bacteria. So we try to find out SOB, SRB, NRB, and acid producing APB, acid producing bacteria. So screening in terms of unculturable diversity, we do many more. But NRBs are faster and they compete really nicely with SRBs. SOB is very slow. So whatever sulfate is produced, sulfate oxidizing bacteria will utilize it. But population is very less. That's the problem. Thank you.
so much, sir. On behalf of organizing, I sincerely thank Dr. Sanket Joshi for his insightful and thought-provoking lecture. Your valuable perspective on microbial technology in actions, from its transformative applications in oilfield system to the vital role in environmental sustainability and the ecosystem restoration, have greatly enriched this conference. Your expertise in and inspiring insights have truly contributed to the success of this event. Now, I would like to invite Snehal sir to give a memento to our distinguished speaker.
As you people are aware, in the afternoon session, we will proceed for the oral presentation, correct? And the person who is coordinating this particular thing, she must have sent one mail to collect the presentations in the email, correct? A few of the presentations she has collected, but still we have a time till the second speaker arrive. Those who have not submitted their presentation, oral presentation, they are requested to submit within 10 minutes. How many students are there? Those who have still not submitted. Few of them can submit, so we can start our session in the time after lunch break.
It is my pleasure to introduce our second lecture, which will be delivered by Dr. Rajesh Patel, Professor at the Department of Bioscience, Bir Narmad, South Gujarat University, Surat. To felicitate our esteemed guest with a bouquet as a token of our respect and gratitude, I would like to invite Dr. Hidin Somi, sir, to felicitate Dr. Rajesh Patel, sir, with a bouquet. Sir. Now I would like to invite Dr. Dhruti Patel to give a brief introduction of our distinguished guests.
Good morning, all students. We have a Dr. Rajesh Patel, sir, Professor, Department of Bioscience, VNSU, Surat. Dr. Patel has over 25 years of experience with significant contribution in metagenomics, environmental microbiology, enzymology, medicinal chemistry, bioinformatics, molecular biology, and interdisciplinary sciences. He has published more than 70 research papers, authored several book chapters, and successfully completed multiple funded research projects. He has also presented over 56 papers in international as well as national conferences. Till now, he guided 8 MPhil and 8 PhD students, and 6 students are pursuing PhD under his guidance. He awarded Young Scientist Travel Fellowship from Center from International Scientific Exchange, Chinese Academy of Science. With a strong citation record and impactful scientific contribution, he has established himself as a leading research in interdisciplinary bioscience. With due respect, I would like to request Dr. Rajesh Patel sir to deliver his talk on AI augmented translational drug discovery, bridging in silico prediction and in vitro validation of natural products. Sir, please.
Thank you very much. So good morning to all. And first of all, thanks to the Nisha and the team of the ISTAR who has given me the opportunity to have the interaction with you all people. So basically, I think this is a multidisciplinary group. We are having the lot of chemists, biologists, and we are having the other group also. But I think that in this room, we are having the more biologists. Is it so? Right? So the presentation is designed in such a way that it is not for a researcher, it is for the beginners. So I'm not talking about the much scientific details of one typical paper or one typical area, but I'll be just covering the area in which in future you can work, right? So right now everybody is talking about the AI. So I'll be talking some aspect of the AI. Of course, we're having the full lecture of the AI, so I'll be not taking the AI part, but I'll be taking the part which is required to be known for the basic chemistry of this. So this is the entire session overview. We'll be starting with this entire session in a simple way. So suppose you are starting your journey, then you can just see that what is the difference between these two pictures. You can see that in this one, mommy is there and one girl is there. Suppose chemically you compare both of them, then what will happen? Chemically, both of them, they would be similar. They would be having the protein, carbohydrate, elemental level, everything would be similar. But why they are different from each other? The body which is dead, it will not have the active metabolism. It will not have the processes which is normally occurring in the cell like this. It will not go for the replication, transcription, translation, or any other kind of the biological activity will not be there. So basically that was suppose you are defining the life, then life can be defined as a series of reaction where you are having the lot of metabolic activity. Some would be anabolic, some would be metabolic. And suppose you are going in a deeper, then you can see that all this activity are governed by the different kind of the enzymes. And except ribozyme, all the enzymes are protein in nature. And suppose you are going in a deeper, then you can see that the proteins are synthesized by the process translation, or that the information is coming from the mRNA, and ultimately information is stored inside the DNA. So suppose you are comparing everything in the life, then you can see that each and everything is coded in the DNA, and that is expressed in some form of the protein. Now, suppose you're coming to the aspect of the drug discovery or any other thing, then you can see that whatever the observable characters are there, for example, the fragrance of the Aishwarya Rai, right? What is the molecular basis of that? The fairness is due to the lower level of the melanin
The lower level of the melanin is due to what? Melanin synthesis enzyme, lesser regulation. So suppose by any mechanism, logically it is possible that suppose you are creating some inhibitor of the melanin synthesis, then you can increase fairness of use. Right? The same way, each and every characters which are observable, for that some kind of the enzymes are required. And if you are creating inhibition or activation of that enzyme, it is possible to cure that kind of the phenotypic characters, whatever is having the defect. So that create the molecular basis of the life. And that is the reason that for each and every diseases, we are having the specific receptors. And for each receptors, you can have a different level of the drugs and other. Now, suppose you are going in a deeper, then you can see that even before going to this also, we had the basically 3 levels of the science. So initial, when you joined the first year, you're going for the simple experiment in the lab. You're observing whatever is there in the live only. You are not dissecting the animal. You are not going for any of the thing. So that kind of the studies are basically known as the in vivo science. Today also, suppose you are finding some drug, then again you have to go for the in vivo study. So you can see that during the COVID period, we had that kind of the news in the market that some vaccines are there, but clinical trial is going on. After that, that will get released, something like that. So what was that? That was the clinical trial which involved the different kind of the live system. So that is the first science which is known as the in vivo. The second science is coming, which is known as the in vitro. So suppose you are dissecting the animal, you are isolating the biomolecules, you are going for the structure, function, sequencing of that part. So that everything will come in the science which is known as the in vitro. So that was the second science, and where normally all the biologists like us were working. Now, parallel to that, you can see that whatever the information technology was there, that is also evolved during this time. Initially, when we were studying at that time, the information was transferred with only the printing material, right? Suppose you want to have some paper, then you have to go to the library, you have to take the paper, you have to take the Xerox out, right? But slowly in the 90s, after you can see that we had the evolution of the ICT technology, everything was stored inside the computer. Then there was the development of the internet and everything was transferred in the computer. And that has led to the third generation of the science, which is known as the in silico science. And this in silico science basically include the science like the bioinformatics, chemoinformatics, where the basic science are merged with the computational aspect, mathematical aspect, and so many interdisciplinary new sciences came. And in this era only we had the in silico computers, and that is the in silico biology. Now we are sitting in the fourth era, that is the AI, and this is the new frontier of the life. So we were the lucky person. We have started with the very basic printing part, and we have gone up to the level of the AI. But you came in the era of the ICT, and you are just coming to the AI. So maybe when you will be of my age, you'll be again getting some new era. Right? So for you people, it is most important that you should learn that what AI is doing and how it will be. Right? So we're just taking few minutes on the basic aspect of the AI to learn that how it can be correlated in the drug discovery. So you can see that how you're riding the bicycle. Suppose you want to ride the bicycle and if you're not learning, then what will happen? You'll take help of your parents, your friends. They'll be just assisting you. So they'll be holding the bicycle and will be riding the bicycle on. So at that time, you will have that fear that suppose somebody is keeping you alone, you will get fall down. So every day they will be running with you. But during that running, only in between, they will keep you alone. So you'll be not knowing that somebody is holding. You'll be feeling that somebody is holding, but you are driving at your own. And like that, on you will be learning. So that is a process by which our bodies learn. Now, after learning for so many days, you can see that now you're expert in the bicycle riding. So you can ride the bicycle, you can operate the phone, you can do the stunt also, right? Suppose you're observing that after some time, when you're putting the brake and you're counting the time which is required to sense from the eyes to go to the brain and from the brain the muscles to get the entire information to get the brake, that is more with comparison to the time it was taken to put the brakes. So why it was that? Because we have trained our neural system in such a way that without knowing of the brain also we are able to put the brakes. So how that was possible? So we can see that suppose we are taking some other example that suppose right now I'm asking you that there will be rain outside after 30 minutes or then what will happen? Immediately you can tell that there will not be rain because you are people from India and you are knowing that in this season there will not be rain, right? But suppose I'm asking the same question in month of July, August, then we'll be looking outside. We'll be checking that what is the intensity of the sun, what is the humidity, and you will tell depending upon that, there will be rainfall. So that is known as the direct observation. Suppose I'm closing the room and I'm asking the same question that there will be rain outside of, then what will happen? Again, you will be not able to see any direct observation, but you'll be observing the person who is coming inside you. Somebody is coming from the sunglass and sunglass is black. So that give indication that but you can have the dark, sorry, you can have a bright sunlight and due to that rain will not be good. So these are known as the invisible or the non-observable characters. Now, what you are taking in this is that you are taking a lot of known parameters, lot of known data, and depending upon that, what things are happening. And depending upon you are creating the model, so that models are basically known as the neural. So as we are riding the bicycle and we are training our muscle to put the brake, similar the computer is also trained in such a way that depending upon so many known data, it can create some kind of the assumption model. And after that, whenever you are giving something unknown, it will be able to predict. Right? So that is the way by which normally this AI and everything is working. So this everything was quite old. So this slide also I have taken very old. You can see that this is the slide which I was showing in the 2002. So from that time only the AI was there on, but people were not aware of. So as a medicinal chemist or as a microbiologist, so many things we were using, but we are not sure about that how it can be popularized, right? But after the COVID, a lot of things has changed. And in this era only, we also had the development of the chat GPT, and that is changed the entire. So that is the one part that we should learn the AI for this part. Now we are just going to the other aspect that now we are having the different kind of the breakthroughs. Suppose you are taking the outbreaks, then you can see that we had the different kind of the outbreaks. So it is starting from the Spanish flu, and lastly we had the COVID. After COVID, also we had the monkeypox, and like that in future also so many new kind of the pandemics are coming. So whenever you are getting such kind of the diseases, you can see that now it is also needed that you have to increase the speed of the drug research, right? So you can see that a lot of Nipah virus, Ebola, every day you can see that after few months we are getting some news for that. Right? So these are the few kind of the outbreak diseases which are coming. Now, when you are just going for the drug discovery problem, then you can see that we are focusing right now on the pandemic, like COVID and others, right? So you can see that whenever the outbreak is occurring, we are just finding some kind of the drug. But at the same time, virus is also getting mutated, that is also getting evolved, and whatever the drug you develop, that will not be of any use. So always you have to find out the new drug. Similar to that also, you can see that in the future, we are also having the main problem due to the antibiotic resistance. So right now also, the next pandemic, which is probably coming, that would be coming of the entire antimicrobial resistance, right? So suppose we are taking the lessons from the COVID-19, then you can say that there is no universal platform or there is no set of the drug which can be utilized for each and every kind of the disease. Every time you can have the emergency of the new drug, you can go for the repurposing. The vaccine, suppose you're creating, then that will take again a long time. And again, the supply chain management, everything was there on you. So in this case, what is important is you have to target which is known to us. So suppose we are taking the human health, then we are having the two counterparts. One is our human body, and second is the different kind of the viruses or different kind of the pathogens which are getting developed. So suppose we are taking the human body, then almost everything is known about the human body in terms of the genomics. In 2002, we have had the entire human genome project. After that, we had the 10,000 human genome project, and a lot of human genome data is available. So that way, suppose we are taking from our side, then we are knowing that what is there in our body. So what we can do is, instead of fighting the viruses or fighting the infection from the other part, we can just study on the aspects of the proteins which are responsible for the creation of some kind of the immunity or some kind of the resistance towards the different parts. So some of the example in this also, that suppose we are taking the COVID-19, then for the COVID-19 or so many other kind of the RNA viruses, the entry point is the cathepsin proteases. You are having some kind of the transmembrane proteins. You can also have the some kind of the fluorine and other kind of the proteins. So that are the proteins which are present in the host. But their presence is required to get the entry for the viruses, right? So suppose you are chopping such kind of the protein, then even though you are getting the virus infection, it will not get spread through very easily, right? So that is the aspect in which now people are working. So now people are working on the aspect which is present in this. So I will just removing some of this slide rapidly. We will be just covering the other aspect also, right? So these are the example of the cathepsin, how it can be utilized further, right? So this is the strategy which is normally taken. Now we are coming to the second part that I think a lot many people have gone for the normal docking process, and everybody must have done the docking with the autodock Vina also, right? So we are not going in much detail of the autodock Vina. We'll be going beyond docking. What is docking with the Vina? So that is acting like a one grid. In that only you have to just load your molecules. You can just have the different combinations, and you can just find out that which is the exact position where your ligand is getting binding. You'll be getting some kind of this force, and that force are basically known as the binding energy score. So that is basically depending upon the physical base scoring that will go for the gradient optimization, and you can also have up to certain limit flexible. Why it is popular? Because that is the open source, everybody can use. Even some very simple GUI is coming Pyrex. So with the one video only, you can also do it at your own, right? So that was the thing which everybody was doing, right? But when we are using this kind of the technique, we are getting so many kind of the results, and that results are also having the so many kind of the loopholes, right? So this is the docking protocol for that. You have the protein preparation, ligand preparation, you have to define the grid, run the docking, and then you have to go for the right process, right? So this is the basic part of the docking of that, right? So we are not going in detail, we're just taking the example of the binding energy, right? So we have to understand the scoring because computer is always working in some kind of the digits, right? So suppose you are having the two component A and B, you want to see that which is binding best, then we are taking the binding energy. Always the lesser binding energy is very good, right? Why lesser binding energy is very good? Because the simple philosophy is like that. That for example, I'm taking your lecture for 1 hour, then we'll be able to sit in this position on. But suppose I'm taking the lecture for the 3 hours, 6 hours, then what will happen? Will come in the recline phase. And suppose I'm going for the lecture for 12 hours, it is not possible, then you will sleep also. In sleep, you can remain for the 12 hours. Why? Because in that case, we are having the lowest energy. So the same thing is done inside that. With the help of the computational part, the entire solution would be ranked for the different kind of the energy, and depending upon that score is done. So that is the basic part of this. So I'll be not taking the strength and limitation and everything, that I'll be just sharing the presentation with you, right? Where it can be utilized, that is also there. Now we are coming to the next part, that after coming of era of the AI, what is getting changed? So there are 3, 4 major changes as came. One is there, which is known as the AlphaFold. I think everybody must have heard about the AlphaFold. So initially the protein folding was the biggest problem that required a lot of computational power, and that will take a very long time to go for the protein folding, right? And even so many other kind of the solutions were taken, but none of them were as succeeded as the protein folding with the AlphaFold is that. This AlphaFold is basically working with the prediction. This prediction is done by using the different kind of the templates and other, and for that you require the computational power, and earlier you require also the knowledge of the scripting. But now with help of the AlphaFold, what is that? That is creating a GUI like your ChatGPT. Simply you can load your protein and you can just tell fold it, so it will fold for you. So you will get the entire protein folding in few seconds of, right? Suppose you want to go for the doc it, then you have to write the doc, then you have to write down the PubChem number, it will also go for the doc. So that much simple it is. So this is the way in which AlphaFold is working. So basically AlphaFold is working depending upon the deep neural network model. So we've taken this model initially in the example, that was a very simple kind of the model. In the deep neural network, there would be different layers. So different kind of the models are created, and depending upon that only that prediction is there. So that is working with the help of the evolutionary alignment. So that will also find out that what is the origin of the protein, and depending upon that, that will also go for that. That will have the attention mechanism, and that will also go for the geometric constraints and others. So this is a way by which it is working, right? So these are the few part of that which is coming, right? So with the help of the AlphaFold, we are having the more than 2,000 million sequences and other, and for that only the Nobel Prize and everything was, right? So these are the few things. That suppose you are going for some kind of the antiviral discovery, then in that case, how you can use the AlphaFold. So you can find out some protein, or that if the sequence is not available, then simply you can go for the you can go for the molding with this AlphaFold. There are some other softwares also like the Swiss mode and other, but in comparison to that, this is quite good. The same software, it will also give you the one more technique which is known as the dip clock, that will come later on. So that is also provided along with this, right? So that is a part by which you can just work, right? So this is the limitation of the AlphaFold enough. Now we are coming to the second kind of things, which is known as the GINA, right? So VINA, I think everybody must have used, but after the VINA, the GINA is, right? So the GINA is basically a model which is developed the AI scoring in this. So you can have a classical document that is physical based. So it will search from the product VINA, and after that it will go for the AI refinement. And whatever the scoring you are getting, that scoring would be changing the entire result. So we will have the entire details on that only. So this GINA is working basically on the conventional neural network part. So that will learn from the binding pattern from the experimental structures. So normally we are taking the protein structure to create the homology modeling as a template only, but we are not taking the binding pattern of that in basic process, which is including the autodoc VINA. But when you are using the GINA, what it will do, it will also go and search for the similar kind of the binding pattern, and depending upon the ligand and protein which is similar of nature, it will find out some kind of the mathematical comparison, and from that only that we create the CNN model. And that will interact the quality by using the AI, and that will capture the complex spatial relationship, right? So that relationship is of 3D. So you can have a 3D active site, and that 3D active site only you can have your ligand. So this is the way by which it is working. So how Veena is working? So Veena basically you can take whatever the pose of the Veena is coming, that output you can go for the restoring by the help of the CNN 3D grid, and you will be getting the neural scores, and from that only you can get the best scores. Again, we'll have the one case study of that, so that will create the entire part, right? The basic limitation for that, you require the GPU. Again, you require the CNS-based scoring, and you can just go for the ensemble scoring. Again, this is open source, but that is available mainly in the Linux platform. So you have to work slightly on the Linux, and then you can get the entire platform. That is one kind of the up to certain limitation. That is a flexible docking, and that results are also reproducible, right? So that is the way it is working. Now, after that, the next part is coming that after this GNAP, even we are having the one more open source that is known as the dynamic bind, right? So dynamic bind is also a docking software, but that is slowly different with this. Suppose you are taking that in this room, you are having the two kind of the chair, one chair on which you are sitting that is of plastic, and one chair which is available over that is the cushion. Now, suppose you are sitting on this plastic chair, then you will be comfortable for a limited period of time. For example, 3 hours, then you will be feeling uncomfortable. Suppose you are sitting on this chair, then what will happen? You will feel comfortable to sit about 5 hours also. Why? Because this chair is having some kind of the flexibility. The cushion is getting changed according to your body shape, and that will not create any pressure on your body. Right? So that kind of the flexibility is happening. So suppose you are taking the entire protein molecules, then protein molecules are also basically molecules which can have the flexibility. The ligand molecules are also having the flexibility. So whatever the rigid docking we are doing with the help of the autodock, we have the limited flexibility that will not give you the real kind of thing. So when you are doing the binding with the, when you are doing the docking with this dynamic bind, you can see that there will be the flexibility in the protein. So protein will also change the three-dimensional structure up to certain level with this software, and even ligand flexibility is added. And from that only you'll be getting the results. So this dynamic bind that will use the diffuse base upon the neural network, right? So whatever the flexibility is there, that is generated with the neural network based model, and that 3D geometry will be created with the help of the deep learning, and that will create the protein ligand co-folding. So that will be the folding binding simulation, and that is more or less similar to your MD simulation, which normally we are doing after the end of this, right? So this is a way in which the dynamic bind is working. Right? After that only, we are having the one more very common software, which is known as the dip doc. So this dip doc is also available as a part of the alpha doc, sorry, alpha 4. So alpha 4 is also having this dip doc only. So dip doc can be utilized in the initial part. So this is also AI powered docking model, but this is working on a blind docking model. Blind docking model means we are not knowing the active site of the protein, and you want to dock your ligand molecule at all the possible spaces, right? So in that case, you can utilize the dip dock. Comparative to this dynamic bind, it is not the flexible in nature, but that can be utilized for the initial score, right? So this is a way by which you can see that that is basically working on the energy optimization, and that is also working on a generative approach. Generative approach means whatever the solutions are there, that solutions are going for the evolution. Evolution is, suppose you are coming for the Viva in the examination, then what will happen? The examiner will ask you one question. Now, the second question will come from the answer of your first question. If you answer something wrongly, then you can have the more questions on it. Suppose you are answering properly, then again the teacher will ask till the time you are not giving able to answer. So that is the way your Viva is getting over. Right? So that is known as the generative approach, right? So in this deep doc, what will be there? One solution would be created. If that solution is having the good score, then there will be some modification will be done inside that one. So that way that is working. And for that they are using the AI-based approach. So that is utilizing the geometric deep learning, and that will be taking all this part. So I'm not going in detail of any one of this, because now in the era of the AI, the detailing can be done from the any tool in any 5 minutes. You can do everything. Only thing is that you should know some kind of the new buzzing keywords and new trends in the field, right? So don't feel that I'm running ahead. I'm running ahead purposefully long. Suppose I'm taking the 3 hours lecture of the GNA, then that is not of any use. Instead of that, you should learn 10, 15 different kind of the new words. Whenever you want to learn it, everything is available. This everything is also created from the AI on. Okay. Otherwise, I'm not that much good in the creating the PPT. So this also is created by the AI. Can anybody tell which software is utilized for that? Anybody has used that? Gamma. So that is very simple. You can just load the data and you can get the full details, right? So don't get impressed with such kind of the figures and other. You should know the content. This can be done by any. So now after that, suppose you are going further, then you can see that evolution of the AI in the antiviral drug discovery scheme. So we have taken this part only. Now we are just coming to the next part. That initially we have seen that we are just going for the approach where we are using the different kind of the targets which are coming from the human body. Right? So that was the one. And after that, the next part is there, which is known as the network pharmacology. So now people are also talking about the network pharmacology. So network pharmacology is like this, that suppose you are taking any part in our body, then you can see that our body is working like a very complex network. Suppose I'm taking the one drug at one position, so that will be affecting the one protein, but that one affected protein that will change the entire metabolic path. And due to that only, you can see that whenever you are taking any medicine and you are observing on the net, then it will be written that these are the side effects, right? So you can take the paracetamol to reduce your pain, but suppose every day you are taking the paracetamol, then that would be hepatotoxic. You will be getting the toxic effect in the liver. You can have a normal medicine which can be utilized for the normal blood pressure, but again you can see that suppose I'm taking the blood pressure medicine for a very long time, these are the symptoms which are coming, right? So that way you can see that everything is getting connected, right? So that thing is normally done in this, and that kind of the science is basically known as the network pharmacology. So that is bridging the gap between the system biology and drug biology. So what is the system biology? System biology is a holistic view. Suppose you recall the movie of this Munna Bhai. So Munna Bhai, what he was doing when he has gone for the operation theater and dissecting lab, no, he was not able to see that. So he was telling that I want to become a full doctor. I don't want to become a doctor of any lab. So initially people have gone for the specialized part, but now we are knowing that everything is connected. So we have to understand everything in a system manner on. So that is basically known as the system biology. So the system biology is basically working like this. So you can just have the understanding the drug effect holistically. So you have to see that what is the multi-target effect of your drug. At the same time, you can also see that some of the molecules that is binding at more than one places together. So before giving the drug only, you should integrate the genomics data, proteomics data, and you have to find out that what would be the effect of your drug at a different part in a bone. So that is the way you should go for that. So this is a difference between the traditional drug discovery and network pharmacology. So traditional drug discovery, like suppose orthodoxina or other you are using, so that is basically working on a single target and you will be getting the drug development with that on. But suppose you are taking the network pharmacology, then that will be utilizing more than one pathways and the entire system for finding the drug. Right? So the key concept in this is biology is working like a network model. In the network model only, you can have a different kind of the node and you can have a different kind of the age. Right? What is the node and what is the age? Suppose you are taking the Anand, then what will happen? Anand is connected with the Vidyanagar. There is a one road which is common between the Anand and Vidyanagar. Suppose somebody want to block the Anand, then what they should do is they should find out a road which are connecting the Anand railway line and road with this Vidyanagar on. And suppose you are blocking that path, then what will happen? The Vidyanagar will get separated from the Anand. So like that only in our body also we are having the full network of the biological pathways. And in that, some of the pathways are having the central metabolites. So the one metabolites it is going for the regulating so many different aspects. So that is basically acting as a node. So suppose you want to kill somebody, then what you have to do is you have to kill that node and of the metabolites. So that is important that how to find out the node. And to find out that only we're using the protein-protein interaction. In short, that is known as the PPI. We're also taking the gene regulations and others. So that will normally it is utilized, right? So this is the normal methodology which we utilize. So this is utilizing the high throughput study. They are just merging the omics data. And again, you are going for the network analysis tool. This is created in which? Canva, right? So this is created in the Canva. So you can have the integration of both of this and then it is working. So we're just taking the few of the tools for that only. So in silico pharmacology, that will work with the basic approach of the systems biology. So you can use the software which is known as the cytoscape that is available freely and offline also it will be working. You have to take the data from the Swiss PDB. You can also take the admin lab 2 and so many other softwares are linked together. So this is the way it is working. So the first thing is that for example, you want to create the entire part, then you have to create the network of all the proteins. So for that, you can create the cytoscape. Second part is that, for example, I'm just working on some of the Indian medicinal plants. So I can take the database from that and I can find out the phytomolecules and whatever the phytomolecules are there that is binding with whatever the proteins are present in a human being that I can predict. For that, again, the softwares are coming like the Swiss target, you can have the super pred, and you can also have the target net. So these are the software. In click on it, it will find out that what is the probability of binding your ligand molecules with the different proteins in the human entire protein. So that will give you the entire part. Then in the third step, you have to go for the collecting the proteins which are involved in the disease. So that is coming from the disgene or the gene part. For example, I want to work on the cancer. And for example, in the human, we are having around more than 10,000 different kind of the protein. But I want to work on the cancer, then I can just select the cancer, for example, 200 protein, which is responsible in the cancer expression. So only that 200 protein I can select. So what we have done initially is the impact has created the entire protein for the 10,000. We are just narrowed down to the 200 proteins which are related to the cancer. And from that individually, we can create the network. And from that network only, you can get the entire part. So this is the protocol by which it is going. So we're just taking a few example of that only. So you can see that you can download and install the cytoscope. After installing the cytoscope only, you can get this 3D viewer and other part. From that, you can get the different data. This is the impact from where you are getting the data. This net, you can just go for the reducing the proteins from that. And by this way, you can create the protein-protein interaction. So you can see that initially separate protein-protein interactions are there. So as we are fusing it, it is possible that you can fuse all the protein networks together. And from that network protein only, it is also possible that you can filter as per your need on. So that will give the entire part. And this will be giving the entire structure like this. So in this, what you are observing, which is known as the node. So these are the top scoring node. That suppose I want to control the cancer, then I can find out that out of the 10,000 initially I've taken the 200 proteins. From the 200 protein, I'll be getting around 10 to 20 protein, which is basically responsible for the controlling the entire cancer. So now instead of going for the random part, I can go for the docking for all of this thing, and that will give the effect of the entire, right? So that is the way by which network pharmacologies work, right? So these are the few application part of that, right? Now we are coming to the second phase. So one part we have completed, that we are just doing the in silico science, right? So as I told earlier that in silico science is not sufficient. Always you have to go for the in vitro and in vivo. So in vivo will include the animals or the human. So for that you have to have the animal house, or you should also have the some kind of the human clinical ethical committee, and so many problems are there. So to avoid that, only people are going from the in silico. In the first step, you have to go for the different kind of the in vitro exercise. So what is the in vitro exercise? So in the in vitro, you can see that instead of going for the normal computerized prediction only, we are just going for finding some kind of the novel, right? So as we have seen earlier in that first figure only, that everything is controlled by the enzyme. So what we can do is, instead of taking the entire cell, you can isolate the enzyme on which you can work. For example, I want to work on the cathepsin. Then what is that? The cathepsin is produced in the human being. So instead of taking the entire human being, I can clone the cathepsin in the E. coli. I can create the cathepsin molecule in the lab. And that cathepsin is basically a one kind of the protein. So that protein I can link with some kind of the chromogenic substrate. And after that, I can check like a normal assay of the protease, that by adding my ligand molecules, that is getting inhibited or not. So that kind of the assays are created, and that assay is basically utilized in the in vitro science. So those who are going in the drug industry after completion of your master, you can see that in the industry they have only two sections. One, in silico, where people are working on the computers, and second would be the high throughput screening, where such kind of this enzyme-based assay is done. Similar to the enzyme-based assay, you can also have the cell-based assay, and that will just find out the mechanism of inhibition, and you can do everything from that on. So that is the second part. Similar to this, you can also have the cell-based viral entry model. So suppose we are taking again example of the COVID-19, and COVID-19 is very difficult to manage. So we are not allowed to work on the COVID-19, but different kind of the cell-based models are available, where some part of the COVID-19 virus or even the HIV virus, which are highly pathogenic in nature, that is cloned in the human cell. And from that only human cell line, that proteins are produced. So instead of working on HIV viruses, basically you are working on the animal cell line, but that animal cell line or the human cell line, that will have the protein which is produced by the viruses, right? So that entire part is done. Then similar to that, you can also have the cytotoxic testing, and you can also have the selectivity. You can use the fluorescent mechanism for that. So that will give you even the intracellular location, that at which place your ligand molecule is binding and what is the effect on it, right? So you are just having the different kind of the part of this, right? So this is the way it is work. Now we are just taking the one example that also I'm not going in detail. I'm just taking the one example of the SARS-CoV Omicron 2. So we were working on the SARS-CoV Omicron 2. The one project was given to my student. So she has started working, but after that, what happened? The COVID is over. So now, even though we are publishing the paper, nobody is accepting. Suppose we are taking the normal COVID, Omicron, and other, right? So that is the reason that we have to find out some other way. So we have gone for the other part. So we have taken this one medicine. We are not going in detail of that, but we have just targeted about the phytochemical part only. You can just go for the initial LCMS analysis. You can go for the identification of all of this. From that only, you can find out what are the phytochemical molecules. Then initially, we have gone for this simple docking by the autodoc vena. Depending upon your control molecule, you can find out that what are the positive molecules, what are the negative molecules, and from that you can go for the such kind of the heat map generation, and you can get some of the molecules which are working on that. So we have taken the two protein, one ACE2 that is coming from the human, and same way we also taken the cathepsin that is also coming from the human. Now you can see that what is the effect of the GINA on the vena. So you can see that this is the blue line which is showing the vena result, and what is the red line is there. Sorry, blue line is showing the CNN GINA effect, and blue line is showing the vena effect. So suppose you are taking the entire portion, so whatever is there on the left hand side, that is the negative one, that is having the lesser value, and whatever is there in the right hand side, that is having the higher value. Suppose I am doing the cutoff, then cutoff is coming around -7. So the molecules which are getting the binding energy lesser than the -7, that can be considered as a lead molecules, but that will be having a very high number. Now suppose in this only I'm adding the CNN, then you can have the upper part. So that will screen only the 14 molecules from the entire. Okay? So this was the data of around 3000 molecules. So from that, by doing the autodoc vena, we are getting to 20, 50. We are not having another logic. You have to go for one by one. But suppose you are reading the CNN, then you can get the best 14 molecules, right? And then cathepsin molecules, you can just go for the again other part. Then at the end, again, you can go for the MD simulation. So MD simulation is a process in which you are just mimicking the entire thing in a real life system. Because docking and other things that is done in a vacuum-like condition. Vacuum-like condition means that will not have water, that will not have salt. But suppose you are giving something in the human body, then that will have again a change in the pH, water molecules would be there, charge would be there. So that everything can be also simulated in the computer, and depending upon the MD simulation, you can go for it. So these are the few examples of that only. So by that way it is work. Now suppose we are taking the same part, that whatever the molecules were targeted, as I told earlier that that was become very difficult to go for the paper with this, with the aspect of the COVID-19. So what other approach you can do is, whatever the molecule you have selected, you can see the pharmacology effect of that. So this is an example of the network pharmacology of the network best lead molecule. So we have seen that lead molecule, and that is acting on a different part of body. So you can see that these are the hub protein which is getting affected with this phytochemical, and many of them that are coming not only in the antiviral activity, but they're also coming in the anti-cancer activity also. So that way you can reshape your entire thing for the entire part, right? So these are the few papers from our lab only, so I will not go into detail of that, but this, all of them, they're using the different level of the entire part, right? So this is the entire strategic insight you can get. And the next era would be antiviral will not be just for the viruses, but it will be engineering the post resilience form. Right? So you can see that whenever the next pandemic will come, you will not have breakfast time. But instead of that, it is better to know the entire human proteome. And from the human proteome only, you have to select the protein which can act as a defensive molecule for the entire. So with this way, you can just work further. So the future lies inside your host cell only. The cathepsin and similar kind of the protein you can target. Comparison to the chemical drug, natural products are very much important because natural products are acting as a system tool. You can see that with network pharmacology approach, one molecule that is binding at so many places, that is not only giving the effect of inhibition, but at the same time that will also give the other supportive action also. Then you can also have the AI-based pandemic measurement. So we have taken the part from the drug discovery purpose. Similar to that, a lot of other tools are available with the AI, and you have to rebuild the entire preparedness for our future outbreaks. So I think that is all from my side. So we are not fighting for the next virus, but we have to redesign that how humanity responds to the old viruses with the help of the AI. So thank you very much from my side. And if you are having any questions, I'll be happy to. I know I'm going very fast, but I know that you people are the generation of the reel. So you can listen only for 30 seconds only. After 30 seconds, you'll be changing the reel on. Okay, so that is also going like reel only. So whenever you're interested, You can stick that slide and you can have the more information. I'll share the entire presentation with you. Okay? Thank you.
Thank you so much. Is there any questions? This is open for the discussion. Anyone from the mass?
They will ask to change the video. Okay, thank you very much.
On behalf of organizing committee, I sincerely thank Dr. Rajesh Patel sir for his insightful and enlightening lecture on AI augmented translational drug discovery. So we truly appreciate your valuable time, expertise, and the knowledge you have shared with us today. Thank you once again for such an inspiring session. Now, uh, I would like to invite Dr. Nisha Darshini ma'am to give a memento to our speaker. Thank you, sir. At last, I would like to invite Dr. Viral Soni for photo. Good afternoon, everyone. I, Dr. Hiral Soni from Department of Biotechnology, ISTAR, on behalf of the organizing committee, am honored and privileged to propose the vote of thanks for this enlightening sessions. It is my great pleasure to express our sincere gratitude to Dr. Sanket Joshi from Amity University, Rajasthan. Sir, your presentation clearly showed the real-life applications of microbial technology and its importance in both industries and in environment. Your insights greatly improved our understanding about the role of microorganisms in solving global challenges. Thank you, sir, for sharing your insights with us. We are equally grateful to Dr. Rajesh Patel from BNSGU Surat. Sir, your interesting presentation provided valuable viewpoints on the integration of AI with translational research. It offered a clear vision of how computational and experimental approaches together are transforming modern drug discovery. Thank you, sir, for sharing your insights. We deeply appreciate both of the speakers for taking time from their busy schedules to share their knowledge, expertise, and valuable experiences with us. I would also like to sincerely thank the organizing committee, the faculty members, volunteers, whose dedication clearly made these sessions possible. Our heartfelt appreciation goes to dear participants for their presence and active engagement. Once again, we extend our sincere thanks to distinguished speakers for their inspiring talks and meaningful contribution. Thank you everyone. So we have this. After that, we